Are we living?
We
Are we
are live
living
right
now?
now. So, so we got
Okay,
Cruz from
everybody.
Elegance Coral and Nick from Aquarium's Cabinet Solution. You two are some of the old school reefers that I know have tried about 8 million different types of filtration. So I figured you guys would be
Oh,
excellent ones to have on the stream today.
old and grey school.
Old is a frame of mind.
You're only old as you think you are. Highly
Exactly.
experienced reefers. How about that?
I'm okay with that.
Yep. So in terms of different types of filtration, there's a few different type of ones. Like I know we have, mechanical filtration, obviously. The other ones
Yep.
would be kind of
Hmm.
like a chemical or additive filtration, where you're dosing stuff,
Yep.
and the other more natural type would be like a macroalgae or natural filtration.
Refugium type. Yep.
Yep. So a few of the like back in the day, I remember like the wet dries used to be a huge thing, and then there was like the trickle kind of filtrations, where it trickles down through all the media, so it's partially exposed to air. And I know you guys use, I've never tried it, but I know you guys used to use undergravel filters or the reverse undergravel filters. There's all kinds of different kind of crazy ones over the year. And then
Oh
in
yeah.
recent years, it's evolved to stuff like turf scrubbers and different types of things. So it's really kind of interesting to see how the hobby's progressed over the years.
Yeah.
So,
And how it loops back too.
mhm.
I was going to
You
say,
know.
would you say progression, or
The
would you say
circle of life,
progression?
little Lion King.
Sometimes it doesn't feel like it.
Yeah. Well, yeah. It's kind of come full circle where they went away from natural method of filtration to mechanical and chemical.
Mhm.
Trying to create that the biological filtration. It extends all the way out to the bacteria. Trying to propagate the right types, the right strains, and then they found out that it's not very easy, to find that media or to find that balance, the right flow, blah 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 blah, the right oxygenation levels. So they went, we're seeing a trend coming back towards the refugiums, or at least some type of bastardization of a refugium, where you kind of split it up into different reactors. You have your Cato reactor, you have your Miraclement reactors now.
Yep.
You have your and then you also have your slow flow. What is that called? The trickle filters, as well.
Mm.
Plus the turf scrubbers.
Mhm.
So there's a blend of old school and new school type of setups that I've seen very, very, very successful.
Yep.
But once again, kind of like what we were talking about before, is you have to understand the concept.
Mhm.
You have to know where it came from, why it came from. The underground, the undergravel plenums, they were very, very popular. And back in the day, and Nick, you can correct me if I'm wrong, but back in the day, there was this huge argument about going, with a sump or
Mm.
without a sump.
Mhm.
You remember? Or
It's
last
almost like
conversation.
everything. Every evolution causes massive debate.
Mm-hmm.
If you notice that every evolution causes massive debate,
The,
and
the,
then somebody will come out with reasoning
Mm-hmm.
behind the arguments, and then some
Mm-hmm.
of that knowledge filters through, and then it sways it one way or the other. That's how I always see it.
One of the funny things is too, I mean, everyone wants to find a better way to do it. And for the most part, I mean, all these systems still work, you can still use them today and be successful. Some are more
Yeah.
efficient, they work better than the other, but they all work. And at the end of the day, we're really trying to get a thriving bacteria population to deal with all the waste in our tank.
Correct.
Well, there's
Correct.
there's two methods though with it, Dev. It's like Cruz covered the biological type methods there, but we're still using skimmers, which is a mechanical extraction.
Mhm.
So what you're
Mm-hmm.
doing there is you're removing the particular waste before it decomposes, to
Yep.
then not have to deal with the resultant decomposition. Where with bacterial and refugium type systems, you're allowing decomposition to take place, but then follow through all the way to where it becomes harmless again.
Mhm.
So you were still using random. That's why people are running filter socks and filter floss,
Yep.
mechanical removal.
Mhm. No in the comments is asking, do you think a refugium could be used as a display tank, almost like a plant tank for freshwater? Yeah, it definitely could. I've seen actually lots of people have really nice display saltwater tanks. Another question from Kyle was asking your guys' opinion on a more natural filtration instead of using filter socks like oysters or filter feeders. No, definitely clams can filter a ton of water.
The only problem with using like oysters and mussels and things like that, because that was a bit of a craze at one point in the UK. And again, you've got to remember that those are animals as well that are producing waste as well, and you got to keep those animals happy and so they work efficiently.
Sorry,
So
I
it's
got enough
how
water.
reliable. You got to look at reliability of your filtration. But yeah, I mean,
Exactly, and the ease
if you
of
look,
maintenance too of the filtration. The ease of maintenance.
Mm-hmm.
That's
so
one of the hardest parts.
so
Yeah.
when you're looking at filtration, for me, it can actually start from the aquascape. Aquascape in the way that it's not going to inhibit filtration or entrap too much stuff, so that then you're needing to boost your filtration because of the amount of rock or dense rock that you've got trapping stuff.
Mm-hmm.
And then
Exactly
looking
that.
at your stock, look at the animals that you keep in that will help you. So stuff that turns
Exactly.
over the sand, stuff that's going to go and scavenge around the rock. So in terms of filtration, it starts from the aquascape and the cleanup crew and the fish you get all the way through.
Got to put your tank to work for you. A big
Exactly.
thing,
Yeah.
yeah. A big thing too, always in the tank, is having proper flow in order to make stuff not settling in your tank. And like you're saying about how you aquascape, you got to make sure that the flow actually can go around your tank and it's not pushing stuff into a big pile of rocks in the corner where it's just gonna decompose in the tank.
But
Yep,
then
and
is
collect
is
over
it
there.
is it important if you don't have lots of flow in your tank and stuff does settle, as
Um,
long as you've put a redundancy in place so that you have enough scavengers and feeders to
yeah, I
then go
mean,
and eat it?
if you have
You
sand
see what I mean?
sifting gobies and sand sifting stars and
Yeah.
stuff are gonna eat it out of the sand, I mean that's another way to combat it.
So that's the thing. So you can sometimes do something where you say, okay, I don't want fast flow in my tank, but that's going to result in this happening. So then how do I combat that a different way?
No, it's true.
Exactly.
So making sure you understand the processes and figuring out, which ones complement each other.
Exactly.
Well, I mean, you guys remember when there was a rule of thumb, 1 pound of rock for every 1 gallon of water, right? Well, that's also gone by the wayside.
Yep.
And that whole premise is over the biological filtration in your system. Once again, that was before they had sumps and everything else. So they loaded up their entire friggin' tank, and basically their display tank was their sump as well.
Yep, all in one. Now
all in one.
these days I find it's almost going more the minimalistic look, and now there's products like the marine pier and those type of ceramic medias that are very porous that a lot of people can hide in the sump and then have less rock in the tank and have it more open and spacious.
Correct.
The only thing that you got to be careful of though with the filter media is whether the filter media is a pocket type filter media. So with ceramics, if you look at them under a microscope and the holes, what you'll see in the product descriptions is often you need to swap out 20-25% a year because they will get clogged and blocked up. And the problem with if you look at filter media and they're talking about big surface area, it's not necessarily the amount of surface area, it's how efficient is that surface area going to be, because you might have 150,000 cubic feet of surface area, but if after a month it reduces down to 50,000 cubic feet because it blocks up very easily, then what use is that?
Yeah, exactly.
So
it's gonna be
it's like
short-lived.
everything, don't always go by the biggest number, look at the efficiency of the media as well.
Yeah. There's one thing too that I've done in my tank is make sure I have that type of media after my filter sock, so at least there's less particles flowing through it. I mean, stuff's still gonna make its way in, but it's gonna definitely reduce the amount that gets sucked
But
through
also think about the bacteria, because you want the bacteria to be replaced by new bacteria. When the bacteria gets old, it's not as efficient. So what happens when it dies? And that itself blocks up. So in your sump, you'll probably notice if you get a very clean running sump, you'll still get like a brown, like powdery, almost like sugar type stuff. That's dead bacteria.
Yeah.
So in sense of the filter media, if even you've got the cleanest mechanical filtration in front of it, the bacteria itself can block up the media.
Correct.
Yep.
It's kind of like a dead. It's very, very fine. Kind of like what Nick was saying. It's kind of like a pile of dead skin cells. You know, over time, you know, you see all this dust, and you don't know where it's coming from, and you know, you're seeing it settle in the freaking corners of your sump, and it's this really, really fine, light brown powdery type of.
Like a diatoms type of thing. Oh, looks like they got dropped off the call. Oh, there you go.
Oh, we're just gonna keep getting booted, I think, Def.
Yeah, I might. I don't know if I could try Skype or something else next time because Hangouts it seems to be happening to everybody, not just me now. So.
Yeah.
Yeah, keeps on dumping us every 5 minutes.
Yep. Something's going
It's
down
our
in
cue
Google.
it's our cue to shut up.
Yep. Kyle's asking, what would you recommend to get rid of the brown powder? Kyle, I know your tank's fairly new, so I'm thinking there's more diatoms in your tank. But,
Yep. So, yeah, with the diatoms, I would actually go with a silicate remover.
Silicate remover? Okay. Is there any additives that you could use for the tank? I've seen them for like RO systems and stuff, but is there?
No, basically, you'd utilize a DI resin, like
Okay.
what is that? Chemipure.
Chemipure blue?
Yep.
Yeah,
Chemipure blue.
GFO also absorbs silicates as well.
Okay.
But just be careful with the GFO.
Yeah.
Another thing, like Reef Keeper's saying, is that what I use in my system is bacterial. So, like he was saying, I dose outbreak colony and things like that, and they'll remove, break down some of that waste matter that the dinos are feeding on. So that's another way.
Yep.
Remove the waste that it's feeding. Yeah, outcompete it.
Mm-hmm.
Yep. It's not necessarily eradication. It's more of an out competition.
Mm-hmm.
And that's, I mean,
of the quote unquote.
To an extent, a good chunk of people's refugiums too is to outcompete any algae in your display tank.
Correct.
Yeah, because you're not putting the refugium, like the refugium algae kills the hair algae, right? It just outcompetes it. So it's the same with, decomposing material in there and things like that, deposits. If you put bacteria in there that will consume and convert that, then that will usually be more efficient than the diatoms. It's a bit like when you cycle a tank, people talk about the algae phase, so that it comes and then it goes. And usually what you notice is after 6 to 8 weeks and the bacterial load is establishing, that's when the algae starts to fade back because the bacteria are out competing the algae for ammonia, as well as the phosphates and and the other stuff that it needs to then grow. So that's why it dies back, because the bacteria buildup then starts out competing it for the ammonia.
So on the mechanical, just to kind of define the different types of filtration. So the mechanical one would be, I guess you could almost consider a skimmer mechanical, a filter sock mechanical, where you're trying to remove stuff before it breaks down.
Yeah.
Now a skimmer is as much maintenance, but like filter socks, for instance, I mean, if you don't take it out, it's just going to break down the filter socks. So they work well if you change them often. If you leave them for a long time, then it's hit or miss. They'll probably clarify your water, but they're not necessarily taking out those nutrients.
Yeah, it's like a tea bag. Imagine a tea bag. The tea leaves are in the tea bag. So the leaves themselves don't go in your tea. But what happens to your water when you pour hot water in? It goes brown because it's leaching through. So the same as this, if you think of the filter sock as the tea bag and the deposits of waste and uneaten food in there as the tea leaves, you're pushing water through that. So tiny, tiny, tiny particles are still going to leach through. So I find using filter floss in the filter sock better, because you don't, not everybody wants to keep changing and washing filter socks. So it's much easier to take out the filter floss, rinse it, put it back, or just take it out and change it. And then your filter sock's going to last a lot longer that way.
Yeah, it's probably a lot quicker than changing a whole sock, which I know a lot of people, it's just the time of doing it where people get lazy.
Exactly, and then people are going to do it more often as well, which obviously then eradicates the buildup. Like when filter socks first came into use in the UK, people would say, when do you change your filter socks? And they say, oh, when it starts overflowing.
Mm-hmm.
So then if you think how much stuff is being pushed through during that time till it clogs up enough to start overflowing, how much of a job is that actually doing for you, you know?
Yeah, exactly. Not too much by that time. So
No.
now,
And it's leaching a lot of it's leaching a lot of the dissolvable nutrients back in. There's a lot of bacteria also that gets trapped in the filter socks, and not only that, but also the copepods and the amphipods and all these other microorganisms. They get trapped in the filter sock. So that was one of the things that we were seeing is when we actually went 100% mechanical filtration, we were running into a lot of issues, especially.
oh, just fell off. Yeah, so Cruz was saying about having a bunch of issues with the filter socks, and I know every time I clean mine, I'm usually pulling out a bunch of the amphipods and I throw them back in my frag section just to kind of do it. So,
Okay, sorry.
oh no, go ahead, Cruz.
Oh no, it was kind of like what Nick was saying is that during that entire time waiting for the socks to clog up, you're basically steeping, steeping on all the freaking organics, and anything that's leachable comes out. So that's all the nitrates, phosphates, ammonia, etc.
Yep.
Coming out of the filter sock at that time.
Now, the next kind of step of mechanical filtration would be more your protein skimmer. Now, this one's less invasive in a sense because it removes that stuff from your water column, so it's not leaching out into it as much. So for kind of people, just a quick overview how it works is your protein skimmer sucks in all these bubbles, it mixes it with the water, and the little bits of organics stick to the edge of the bubble. It kind of is attracted to it, and then it works its way up and pops in the cup. And it essentially leaves all that gunk in the cup, so it's not in your water system anymore.
Correct.
Mm-hmm.
That is the premise, and there's typically three types of skimmers. You remember the old Venturi, the one that we still utilize today.
Mm-hmm.
That one. You also have the what is that other one called? The Beckett's, right, Nick? The Beckett's skimmer.
Yeah, sorry.
Actually, where you're actually sucking in air and pushing water at a higher pressure, getting the bubbles. So there's no mechanical limitation on how small the bubbles can actually get. So I find that the Beckett still produces the finer bubble, even though it's not as popular as the needle wheel.
Yeah.
The needle wheels actually mechanically limit how small the bubbles can get. They're not very small at all. If you notice, you could actually see them. It's like, you could actually see the bubbles. They're big. You could see through them. So the premise of the detritus sticking to the bubble is a lot harder than having the bubbles, the very, very fine bubbles sticking to a detritus particle and lifting it up and making it buoyant. So that's one of the reasons why the Beckett does really, really well. The second one, I would say, that is more efficient than the needle wheels would be the air-driven ones. So it's Beckett's first, air-driven skimmers with counterflow.
Yep.
And then the needle wheels as being efficient. So a lot of the needle wheels I don't see as efficient at all in actually creating that foam head.
It's kind of funny considering that it's probably the most common type out there too.
Oh, well, it's because it's cheaper to make, cheaper to manufacture.
The other thing as well is like some of the other skimmers run on like the mesh, which chop you a finer bubble. So finer bubbles, more surface area for the particles, so a better grab on particulate matter, but they clog.
Still limited to the thickness of the mesh.
Yeah, and they clog easy. So it's a case of
they do.
who wants to strip it out and clean it. So sometimes it's a case of it might not necessarily be the best, the most efficient, but if you're not going to want to keep changing it, and washing it out, then how efficient is the mesh going to be anyway?
Correct.
So it's almost like the lesser of the two evils. The fact that you probably won't need to change, clean out your pinwheel as often, even though it's not as efficient overall.
Less maintenance, so it probably will be.
Yeah, exactly. Yeah.
Yeah. Once again, the less efficiency. Are you really pulling out what you do on the first pass, on the second pass, on the third pass? little things like that that a lot of people take for granted. They don't truly understand, the limitations of the needle wheel. Even though it might be slightly bigger bubbles, it might be less efficient. They don't see that. They don't understand the true concepts of why the needle wheel became so popular, and it was because of cost.
Mm-hmm.
It's easy to take off the friggin' skimmer, the water pump with the needle wheel.
Yeah.
It's a lot easier to maintain than the Beckett's. The
Mm-hmm.
Beckett's is actually hard plumbed in, and typically, you need to have an overflow and overflow bypass, blah 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 blah, so on and so forth. So you're utilizing the pressure from the downstream of the overflow return to actually drive that Beckett as well.
Yeah.
And it's a little bit more noisy because
Mm-hmm.
it is sucking in the air very, very finely too, under pressure. So even.
But then Dave,
Just dropped him again. So on the one kind of noisy note he was just saying too, another thing that's kind of funny. I know on my tank, I'm like anti-noise, so I try and make everything dead silent. But that also means less water movement, less flow, and less aeration. So that's kind of another kind of catch-22 with having a silent tank.
but you think as well, Dave, what Cruz was saying about the skimmers?
Yep.
What did you do on your tank to make your skimmer more efficient?
What have I done to make it more efficient?
Uh-huh.
Well,
Sorry, I'm back.
one thing that I've added to my skimmer
Use
is,
the ozone, right?
yeah, so I inject ozone to one port for a couple hours at night, which will help it break down the stuff in the tank quicker, make it more efficient. It also helps clarify the water. And then on the flip side, my other little intake nozzle, I have a little tiny line running outside, which helps boost the pH a bit.
Yeah, so on with the ozone, what that does, it breaks down the particulates in the water to smaller particles.
Mm-hmm.
That means it can cover each bubble more efficiently.
Yep.
That the skimmer's producing. So then even though you're using a pinwheel skimmer, you can still increase the efficiency at which it works by using the ozone.
Mm-hmm.
Yep.
No, exactly.
Yeah, we've also utilized hydrogen peroxide directly into the intake of the skimmer.
How much of that?
Basically go ahead.
Would you do like a constant drip?
Yeah, you get a constant drip when your skimmer is on. Otherwise, it's shut off with the solenoid valve.
Interesting.
When the skimmer's off, when the skimmer's off, the feed's off.
That's Deb's next video.
Did it make much of it? Did it make a big difference, or did it make much of a difference?
Oh, absolutely. Because remember, inside the friggin' skimmer, you're also taking up, or the skimmer's taking up a lot of the bacteria that's in the water column itself.
Yep.
And the bacteria has how do you say it? A membrane product called catalase.
Mm-hmm.
The catalase actually reacts with the hydrogen peroxide on the molecular level, causing even finer bubbling.
Yep.
So with having the hydrogen peroxide and or the ozone, because the ozone works very, very similarly, is that it would actually lyse, and basically it'll split. The ozone will split into oxygen and into oxygen.
Mm-hmm.
So you'd have two oxygen molecules per. Sorry, 1, 2, 3. Yeah, 3 oxygen molecules for every two ozone.
Mm-hmm.
And then the hydrogen peroxide, of course, just breaks down into water and oxygen.
Yeah.
So both of those things, what they're also doing is a byproduct. Like you were saying, you've got slow flow. So if you utilize that on your skimmer, one of the negatives about having slow flow and low turbulence is less oxygen saturation, because turbulence helps the water to hold oxygen.
Yep.
So by using the hydrogen peroxide and the ozone is another way to increase the oxygen saturation with the water to counteract that.
Yeah. So that's interesting. I am actually kind of tempted to try this, see if I notice a difference. So far, the main thing I've only used Prox H2O2 in a tank for is spot treating and killing algae, which seems to work very well, by the way.
Mm-hmm.
If you turn off your flow and you got a little patch of little hairs or anything, you can just give it a little shot of that, and it seems to kill it pretty well. Pro tip.
Yep. So yeah, they used to call hydrogen peroxide the poor man's ozone.
Nice.
And I mean, That's where the whole premise of basically injecting or dripping hydrogen peroxide directly into the air intake of the skimmer pump was that was how we were able to actually get that oxidation and actually the lysing of the bacteria, so that we could actually remove the exploded bacteria and actually skim it out right there at the point source.
Yep.
Instead of having dosing it throughout your entire tank, things die where they may. They may or may not get exported out. Whereas if you do it at the freaking protein skimmer, you know that's exactly the point of exit.
Yeah.
Explode the bacteria, you cause the micro bubbling or the nano bubbling at that point at a molecular level. You're lifting out the nitrates, phosphates, and other nutrients that bacteria was carrying directly out at the skimmer itself. So you'll see the skimmer actually overreact with every drop.
Huh.
We do it. I think for a normal day, we dose about 3 mils of hydrogen peroxide, spaced out over 24-hour period.
In what size of the system?
This one was 120.
Okay. Yeah, you don't want
to
be
who was
dumping.
Yeah, turbocharges your protein skimmer.
I'm curious to try
it
later.
Who was one of your mentors that wrote a book and discussed hydrogen peroxide use? Did he pass away last year? Albert Thiel.
Yeah, Albert.
Thiel? Yeah.
Albert.
Alex one out. So Albert Thiel, he was a big nano reef guy actually. So they come back on. And I know he did write a couple books mainly on nano reef keeping, as far as I know. I haven't read the books, but I've seen lots of good things about Albert's.
Yeah, well, he left his posterity behind. So there's a lot of interesting articles that he wrote. He was the one that actually encouraged me to share with the hobby the micro nano bubbling. He told me, if you believe in this method, tell them about it, and it'll prove itself over time.
Yep.
And so I grew a backbone on that, and I decided to share it, and I got flack for it.
Yeah.
If it wasn't for him, I wouldn't have shared it, because once again, it was one of those topics that were taboo. Putting oxygen into your system, right? It's taboo. You don't need anything more than a protein skimmer.
Well,
which you guys have seen it. You played around with it. And
yep.
Yeah. How many people know exactly how to size the skimmer without somebody telling you that this skimmer is rated for this tank?
Well, okay, this is another side rant. They say what size of a tank a skimmer is rated for, but really it should be based off the load of your tank. But I know there's no easy way for them to quantify it. They're not going to say, oh, this is a 20-fish skimmer or a 60-inch skimmer. Like that's kind of the hard part to do it.
Exactly.
Yep.
And that's where where my cousin Nick was talking about it. Being able to pick bioload. Now, does your fish eat? Is it a vegetarian or is it a carnivore? Or is it an omnivore? And you have to be able to actually balance that. There's a lot of people that have a lot of the fish that eat myces, but they're not understanding that there's also there needs to be a balance with the herbivores as well. In the system. Crabs, herbivores. So how do you balance that? How do you balance that equation out? Because the more carnivores you have, the more nitrates you're going to produce.
Yeah. Well, on the flip side,
can you imagine, Dev, like if you were picking stock according to how your filtration was to be run?
Say it again,
so instead of just what we're talking about is in terms of like you can actually pick your stock of your tank according to how your filtration how you want your filtration to run. So if you imagine like you get something like a rabbit fish, which is going to eat a lot of algae, what's its waste? What waste is it going to produce into your tank compared to a meat-eating fish?
Yeah.
Yep.
What type of waste is it putting into your system? So even the stock that you choose can determine the level of filtration that you need.
No, it makes sense as well, right? And that's why I always laugh when it says, this is good for a 100 to 150 gallon tank. But a 100-gallon tank with 3 fish in it, one with 30 fish in it, are two completely different stories. So it's
But
kind of
also,
neat.
you got to look at
Correct.
it as a system.
Yep.
So, how reliant on the skimmer are you being
Hmm.
in terms of what other filtration methods have you got in place, and what are they going to contribute to the system as a whole? So, if you've got lots of other filtration methods in place that biological or the mechanical, and you're looking at your careful stocking and the types of foods and how you feed, etc., then the weight of workload on the skimmer might not actually be a lot.
Hmm. Well,
So then you've
exactly.
got to start questioning whether the skimmer is, because skimmers are indiscriminate. They'll take out
Anything.
good bacteria and other good stuff as well
Hmm.
as the waste, right? So then it's, do you need the skimmer or do you run the skimmer all the time?
Well,
You know,
that's another.
sometimes it's good to give the tanker rest from
Yeah,
skimming.
that's another good point. I mean, on one of my nanos, I used to only run the skimmer at nighttime. I wouldn't run it in the day. I partially did it because it was just annoying and loud. But on the flip side, if you're dosing stuff, your skimmer very well will be taking out some of the stuff you're dosing to the tank, right? So it's kind of a catch-22 to an
Mm-hmm.
extent. But on the flip side,
So
for
that's,
somebody new, it's going to make their life easier and less maintenance having a skimmer than not having one, right? So I mean, there's pros and cons to both sides of looking at it.
but is it? That's the question though, is it? Because that's the fear, is that, we need these products. But for example, the rock, the old,
Hmm.
like Cruz was saying about the volume of rock that you need per gallon of water,
Hmm.
is that because we're scared of not having enough bacteria? But are we looking at the entrapment of food and waste that rock's taking up? So is the amount of rock we have actually hindering the system
Correct.
adversely? So
Oh, just lost Nick. Yeah, so kind of on Nick's things too, but having too much rock could be trapping stuff in your tank and make it more of an issue than not less rock.
yeah, exactly.
Yeah.
Because if it's not trapping in the rock, is it then going through the weir and then into the filtration?
Hmm. No, exactly. So now on the, since we're bridging over to some of the other stuff, so on that, so having a refugium, so running a tank with just a skimmer, a tank, and a refugium, same thing, like those
Yeah,
macroalgae are going to absorb those nitrates and phosphates. Now they can also, to an extent, act as mechanical filtration, because having a big mass of Cheeto that water is flowing through is going to capture a lot of those little particles in your tank and help clear your water as well.
exactly. And then that in turn, the entrapment of that, then in turn feeds the pods and
Hmm.
the other microorganisms,
Mm.
in the system. I mean, you've seen a lot of bristleworms. I'm sure a lot of people have bristleworms in the
Hmm.
Cato mat. There's a lot of, pods, amphipods, copepods, isopods that we've seen there too. Plus, we've also seen bacterial,
Yeah. Actually,
developing over these. Yeah.
on Paul's stream, just when I joined the other day when I was cleaning out my Cheeto reactor, there's these weird little like ribbony worm looking things and all kinds of random stuff that was inside of my Cheeto reactor growing in there. So you never know you never know what's living in that ball of Cheeto.
Exactly. But
Yep.
I mean, a lot of them are beneficial in breaking down, particulates. A lot of uneaten food,
Hmm.
and or eating high fiber foods.
Hmm.
Like say from the rabbit fish or the tangs
Yeah.
that actually produce it. Gets floated over to the overflow. Well, these guys, this filamentous fibrous type of waste product needs to get broken down even further.
Hmm.
And what better than to actually feed the all these other microfauna, in the system naturally.
Yeah.
They in turn break it down, and then now that nutrient, after it's broken down into a usable form, biologically usable form, now gets pushed through your system, and now your corals can actually benefit from it.
Mm-hmm.
Hmm.
You know what I'm saying? And that's one of the things that we're noticing, that if we mechanically, how do you say it,
Strip.
filtered out all the
Part
freaking organics and all
particle
the
filter. Hmm.
particulate, exactly, before it could actually break down, you know, are we now overstripping the water of nutrients,
Mm-hmm.
of actual organics that could actually feed the system? Yes.
Yeah.
And I think that we've seen that, there is a huge potential, when everybody was trying to drive, their nitrates and their phosphates down to zero. we saw the opposite effect. We saw STN. We saw a lot of the the breakdown of the actual coral ecosystem if you actually filter too well. And over skimming is also another issue, and then also overutilizing carbon by the water.
Mm-hmm.
So yeah, there's multiple in the mechanical side, in the
Yeah.
mechanical filtration,
So
that would tend to over clean a system.
yeah, no, for sure. With like, cause I do run a bit of carbon and a bit of GFO, but I literally run it like a little tiny trickle of a stream, like super duper low, just because I mean, too much can be like you said, it could be harmful to the tank. Too much carbon could strip everything out. Too much GFO can strip away like some of the zooaxils and some of the stuff and like literally take out your corals if you run too much of it. So less is definitely more with a lot of these things.
Correct. So, I mean, that's why we see a push towards the natural way of filtering. Again, utilizing macroalgae, because the macroalgae cannot and will not how do you say it? It won't overstrip, because if it starts overstripping the water, the plant itself starts breaking down.
Yeah, it starts killing itself.
Yep. Now,
so if the plant starts dying, it starts releasing the nutrients back into the water again. So that way you never ever get a true zero.
Yeah. That's why you get leaching back of natural sugars and amino acids back into the system. Now, and that's why when you get your macrofauna like dying off, don't harvest it out. Let it ferment, let it decompose, and let it leach back.
So a lot of that stuff is actually like your amino acids and stuff you can even get out of like the dying chaeto. Like there's lots of good stuff that comes out of it too.
Yeah, natural sugars as well. So natural sugars in our aquariums, we don't have much of a carbon source in an aquarium. So when the algae die back, if you leave it in, so it goes all purple.
Nope, just lost him again. Ash, we have skimmers, refugiums, chaeto reactors, miracle mud, UV sterilized, mangrove pods, carbon, GFO. Ash, you have absolutely almost everything in there. I think you're just missing a chaeto reactor and a turf scrubber.
But yeah, if you let that stuff ferment down and bubble and go all purple and break down, it actually releases natural sugars, which is a carbon source then. So then what you're doing is you're feeding the ultratrophic bacteria with carbon source.
Yeah, no, it's interesting. All like basically the natural ways of doing things. I know right now I have my chaeto reactor, but when I redo my sump, I'm gonna try and make at least a spot for a small fuge to throw them back in, because they are a lot better for pods as well.
Well, the other good thing with a fuge is that then you're going to use like a substrate like miracle mud or a deep sand or something like that. So within that, you're then creating anaerobic zones for bacteria.
I actually have been on my new sump design. I've been like trying to plan the chambers. So actually, I bought one of these acrylic trays so that I can fit them in each of the chambers and sneak in more miracle mud in the system.
Very nice.
Yeah, so it'll be good. Nice. So I'll have it in the chaeto area, and then I got a big strip along the back for which is going to be for reactors return pump. I'll be able to fit a bunch in there, and then probably another frag rack again. So that's going to be everywhere.
And once again, we're not suggesting that you let the entire freaking macroalgae die and decompose completely. Do you know what I'm saying? We're talking about just a little portion of it, probably about 10 to 15%, right, Nick? 10 to 15% of decomposition is fine. That actually releases a lot of the nutrients back into the system naturally. Where you don't have to worry about it.
On that note, though, usually if your chaeto isn't necessarily tumbling or something, it's the bottom half of it that's going to not be getting the light that's going to die off a little bit. So, and again, a bit of that is actually very beneficial.
Yeah. But one of the things that we did find is, with the right light, is that the top part that's exposed to the air, because it's a floating matting type of macroalgae, is that, the top part would actually start decomposing.
Oh, really, eh? In my experience, it's been more the bottom than the top. Huh.
Yeah. Well, I mean, we also utilize very, very high lights.
Yeah.
Utilizing the 3000K, we're also utilizing the 5000K floodlights.
So on that note,
LEDs and otherwise.
Have you noticed a difference between like 3 and 5,000 K?
Well, 3000K is a little bit warmer. You see a little bit more orange.
Mm-hmm.
We get darker chaeto growth and tighter.
With
With the 5000K, we get the explosive growth.
yeah.
So if you want long and stringy, go 5000 and cooler to upwards of about 6500.
Mm-hmm.
We tend to stay at 5000K because it's very, very readily available as neutral white
Yeah.
in the in the stores, in the Home Depot stores, the home improvement stores like that.
Mm-hmm.
And then the 3000K, which is the warm, the warm whites, we notice definitely thicker growth of the chaeto. We see tighter curling
Mm-hmm.
and darker greens.
Now, aside from like the aesthetic differences, have you noticed any difference? I guess it's kind of harder to compare, but in nutrient uptake between like the thicker, more compact versus the longer stringy?
Longer and stringy, I tend to find that it's not as efficient as removing the nitrates.
Okay, so the thicker,
Phosphate,
darker.
the thicker and darker actually pull up the nitrates and also utilize ammonia,
Mm-hmm.
in the macroalgae. And, that's where you are also getting a higher thriving values in the red macroalgae as well,
Mm-hmm.
in the lower spectrums. In the cooler spectrums, we notice that, let's see, what is that? The calciferous, or, oh gosh, what is it called? It's that macroalgae that actually forms the skeleton.
Oh, really? I have no idea what that one is.
What is that called? Nick, help me.
Well, the
Intel.
yeah.
It's that macroalgae. It's Halimeda,
Oh,
as well as the other one, the one that looks like cactus.
I'm Googling it right now.
I don't know which one you mean with that one.
I have no idea.
Yeah, it looks like a cactus.
No.
It starts with the C. Gosh.
Calerpa?
No, not Calerpa.
No, I have no idea which one you're talking about. Okay, another question.
Yeah. Codium. Sorry, codium.
I have to Google that. I still have no idea.
Yep.
So
take a look at it real quick.
okay.
So codium and Halimeda are the ones that actually build the skeleton. They actually utilize the calcium out of the system. They actually tend to do better with higher temperature Kelvin.
Okay.
So you're talking about the 65, 7500, or the 7000K. So.
Interesting. So I've been so far, like at least on my Chaeto reactor, I've tried running warm lights for a while, and then I've also tried running cool lights, and so those have been kind of my two recent experiments. I haven't tried it yet, but I've been meaning to try the red and blue light and see if there's a difference between the warm light or the cool light. So Cruz, on yours, have you guys tried like the red and blue mix as well and compared it to the warm and the cool light spectrums?
We have primarily, and we utilize that instead of utilizing the white, and we noticed a little bit. It's kind of like we experienced a die-off on certain macroalgae, and then it regrew, and then it was able to actually utilize that purple light, the red and blues only.
Mm-hmm.
But yeah, when you get it from a source that's used to the red and blue lights,
yep,
they typically do really, really well underneath the red and blue lights only. Whereas if you're growing it, or other people are growing it underneath full spectrum or in sunlight, when you actually bring it over to the red and blues, at least parts of it die off, probably about 80%, they melt away.
Mm-hmm.
And I think that that's one of the frustrations that a lot of people are having, is that they go, oh yeah, well, I've been trying to freaking grow chaeto underneath this freaking UFO light, and it's dying.
Yeah.
I can't keep it alive. So I told them, I was like, well, switch out that red and blue light with a freaking full spectrum white,
Mm-hmm.
or at least a broad spectrum white,
now,
like a neutral white.
Another thing with that too is you almost sometimes have to acclimate your Chaeto almost like you would a coral. Like if it came from a tank that was very low par and you're throwing under like one of those crazy Kessel lights, I mean, you could very well bleach it and kill it out that way too. So if you are
Absolutely.
putting in a very intense light, maybe you want to start with it 3 hours a day and then a week later go to 4 hours a day and just build it up to that. So it's not just instantly shocking with an intense amount of photoradiation.
The good thing with the Kessel light, though, is that the unique thing with Kessel, I should say, is that the original lighting was for plants. And so they have a whole laboratory in California, a research laboratory where they tested the diodes and stuff. And that's why I was excited that they went into aquatics. And when they launched the Refugium light, for them it was like the perfect product, because with the algae, it was more of a background that they were, they were really well versed in. So
what company
I
or who
would
are you
say that
talking
the
about?
Kessel would be
Kessel.
Okay.
Kessel.
Yeah.
So I would say, I would argue that they would probably would have more expertise in creating a refugium light than other, a lot of other lighting companies.
Correct. And
The
if you
unique
notice,
thing about the Kessels as well
yeah,
is that the actual phosphorus coating that they put on the diodes is what they do themselves. So they don't buy Cree, Bridgelux, Semi-LED, Philips Rebel diodes from LED manufacturing companies. They actually create their own phosphorus coatings to provide those unique spectrums under their research.
Yep.
Yeah.
So
correct.
that
Very
would be
similarly
a good
to
light.
ReefDudes too.
Yeah, same
Yep,
as
ReefDudes does
Tulio
the
does
same.
with
They
Reef
create their own.
Yeah.
Well, isn't Kessel almost more of like a horticulture light first and then aquarium second?
Yeah, because that was their background. But who better? Because when you can create spectrum on diodes rather than having to buy a pre-manufactured diode
Package.
it's almost custom.
Yeah.
You're bespoking that
If you
diode.
actually notice, if you notice the Kessels, is that they don't just in blues. They mix it in. They mix it in with a lot of the whites, the warm whites. The warm whites and the neutral whites.
Yeah.
It's not just all red and blue, like the Chinese UFO lights. So, being that they were forefront runners of the horticulture, agricultural, the in-house, indoor greenhouse type thing, trying to keep ficuses alive and stuff like that. I mean, there's got to be validity that they're not utilizing primarily, red and blue only.
Yeah,
You
no,
know
for
what
sure.
I'm saying?
I mean, I think that's probably the majority of it, but they definitely take advantage of the other lights as well.
Oh, absolutely. Because the other spectrums found in the white light, we still don't know. I mean, absorption is one thing, but what about the other transport and signal wavelengths? Telling the plants to be more efficient.
Yeah.
You know what I'm saying? They don't have that in the red and blues only. Absorption is one thing, for chlorophyll A and chlorophyll B. But once again, what about the other chlorophylls? There's a lot of other chlorophylls like chlorophyll C.
No, exactly. And I mean, having a white or a full spectrum light gives you all those different colors in one. So that, full spectrum with LEDs for the most part is actually like a mix of many different colors. Like your red, green, and blue is almost your white. So I know the warmer or the cool lights have that blend. Yeah.
Dev, do you know what when Cruz mentioned the chlorophyll C? Do you know about the chlorophyll C?
Not in depth, no.
Do you know where that generally exists?
I'm Googling it right now.
It generally exists in algae.
Really?
Chlorophyll C, yeah.
Yeah, exactly. And then you also have your carotenoids. Then you have your, your oranges, your reds. Those photosynthetic cells as well. They're not as efficient as chlorophyll A and B, but they do play a role in overall plant health. And they're there for a reason.
Yeah.
So when you're thinking about your chlorophyll A, B, and even C absorption points, those points are what we're talking about there is providing the light source for those absorption points. So in relation to your lighting, you've got to look at the spectrum. And when you look at chlorophyll absorption points within spectrum, like chlorophyll A, talking around 400, 450 nanometers. Yeah. So when you're looking at your lights and you're looking at the spectrum graphs, that then you can see where the spectrum is depicting is where it's hitting those points. So when you're saying, well, will this light be good for my algae? When you look at the spectrum of that light, is it providing a chlorophyll C absorption point in the light? and that will then tell you.
Mm-hmm.
Yeah. But once again, with the LEDs, remember that they're bandwidth specific, which
Mm-hmm.
means that it's either hit or miss. If you're missing the 445, the 445 to 450 nanometers, to 455 even, because there's a bandwidth
Yeah.
for that for the chlorophyll, the absorption bandwidth. Yeah, even though the peak may be at quote unquote 450, 449.5 or whatever,
Mm-hmm.
it's having the base of that peak spread out over over that broad wavelength
Mm-hmm.
actually increases the efficiency of that freaking chlorophyll.
Yeah.
So, it's not just, I just need this point, this point, this point, and this point. Well, you also need the blends around it.
Yeah, I call it bleed, like the bleed into the other spectrum.
Correct. It's a bleed across light wavelengths. So yeah, when it comes down to it, the biological filtration of macroalgae is a science in itself. Kessel is one of the better ones. Reef is another one that's really, really good at it.
Mm-hmm.
If you actually take a look at some of the other lighting for planted tanks and stuff like that, they really, really, really work it towards the whites or a blend of whites.
Yeah.
And they're all at different excitation points.
So I'm just looking at a graph of different wavelengths. So chlorophyll C looks to be more around the, I'm going to say 440 to 480 nanometer range.
Mm-hmm.
Mm-hmm.
Yeah, actually, I'll just drag it over onto the background, so kind of shows all the
that's a whole.
spectrums.
Honestly, Dev, that's like lighting. It is a whole separate topic. It's a massive area that for me, more reefers should really learn about research, because if you think about your coral, it needs good water parameters, and we generally reefers know how to test water for what's in the water: calcium, magnesium, strontium,
Primary.
and your phosphates, nitrates, ammonia, right?
Mm-hmm.
But when you talk about lighting, it's a reflection of that. 80% of the food for the corals comes from the lighting. That's how important it is. So shouldn't we know about chlorophyll A and B absorption points? So like you said, you can look at a light, look at what it's providing, and say, yes, this light is going to work. This light, looking at those spectrums, is providing what my corals need.
Yep.
That's
or
for me.
Or they say that it will.
Yeah, and it's for me, understanding the lighting is a lot of reefers in my experience kind of, does the light look bright enough? I stick a par meter under it. Is it giving enough par? But it's not, all it needs is a little bit of research, probably the same amount as when they first got the aquarium, looked into water chemistry. It's the same.
Yeah, same kind of thing. I mean, so in a reef tank, your lighting and your flow are probably one of the two biggest important things. The third one would be like your parameters and stability. So, I mean, your lighting, your flow, and then stable parameters are basically the three key important things in your reef tank. Kyle was just mentioning the comment. Spectral bandwidth is a proper term about talking about the wavelengths.
Well, spectral composition
Mm-hmm.
and also spectral weighting is probably what he was trying to hit.
Mm-hmm.
Spectral bandwidth is almost infinite, because you go all the way from well past UV all the way up to freaking infrared and well past that as well. That's the bandwidth. The only thing that we see that our par meters can see is what we call visible light.
Yeah.
Mm-hmm.
We don't. I mean, we're still playing around with what's the difference between utilizing a halide to actually grow plants versus utilizing LEDs.
Mm-hmm.
And one of the key missing points in an LED is that it produces no UV.
Yeah.
Mm-hmm.
If you take a look at all the hobby lights, they don't go below what they would call 395.
Yeah, so
which
true
is,
UV.
Yeah.
Now,
so there is no true UV in the UV spectrum in an LED or a typical LED light fixture.
So from my understanding, that's mainly because the UV diodes actually burn out fairly quickly, so they have a very short lifespan.
Correct.
Yeah.
Yeah, they're more expensive. They burn out quick. You have to drive them hard. I think I think there's a couple, but I think the only company that really comes to mind with the UV, which have looked at it and done something about it, is to give them credit, is OFA at Orfec.
Mm-hmm.
If you look at the Orfec Atlantis, which is their current light, they put UV diodes in there.
Yeah, and not only that, but what ReefDudes has also done is that they have removable bars. Do you know what I'm saying?
Yeah.
It's like they have a dedicated module just for that, for the UV spectrum.
That's right.
And you can swap it out every.
You can't even see it. Yeah, it doesn't even look purple.
Really?
You know what I'm saying? It's true UV.
Mm-hmm.
Yeah.
You know, and you get that bluish color light.
Yeah.
Not the purple.
Well,
purple is hyperviolet.
Yeah, and I mean, purple is originally that phosphorus coating they put on the bulbs to block all the rest of the spectrum, so only the UV could sneak through it.
Yeah, it's not. The thing is, it's not UV.
Yeah, no, I think that's why people associate
UV,
it.
But it's violet.
Yeah,
it's violet.
Exactly.
If you see a fixture that has 400 nanometers, 410 nanometer diodes in, and they'll tag it UV, and at the 400 nanometers, you'll get, even with the LEDs, you'll get a very slight bleed into like the 395 and 380s, which is just verging into UVA.
Yep.
But it's a tiny percentage. But because it's there, all of a sudden that's UV.
Claim it. Yeah, they want to claim it.
Better to know UV, I guess.
Yeah, it's like full spectrum LED. You know, when you hear full spectrum in your mind, you're thinking I've got an equivalent amount of every single color in the spectrum.
But you don't.
But
yeah, because each one's a very specific band, right?
A percent of green, a percent of red.
Yeah.
Exactly. So you might get a tiny little bit of some of the spectrums, but because it's there, well, it's full spectrum.
And
so
and what's funny,
things like that.
Exactly. And what's funny is that we see a lot of the dosing regimens, and I compare the dosing regimens to LEDs. They're only element specific. Whereas if you actually utilize, a substrate such as, what I would call broad spectrum nutrient and elemental substrate, such as Miracle Mud, you get the broad spectrum, very, very similar benefits as utilizing a broad spectrum halide, or full spectrum halide. It fills in all the gaps of all the other stuff that's not there.
Yeah.
You know what I'm saying?
We covered
the dosing regimen, the Red Sea colors, and and also, like say some of the aquaforest and the other dosing regimens, like Triton, they're band specific and they're very, very narrow and only dedicated to that particular. That's specific. It's what we call absorption. You remember what we were talking about, Nick, as well, the absorptions. It's great that we know that it's utilizing that, but what about the consumption side of it? We don't truly understand that, and that's where having a broad spectrum trace elemental base such as Miracle Mud actually fills in all the other unknown gaps.
I just call it like a trace element battery. It's just kind of like your backup reserve for if something's lacking, you can suck it out of the mud.
Exactly.
It's going to buffer.
Yep.
Does that cover refugiums stuff?
Yeah. All right. So we're at it. Another big one is, so back onto the filtration subject, is there's sumpless tanks, or you have tanks with your sump. Now, when it flows through the sump, another big one too is refugiums. And for a while, people were, without them. Now they're kind of almost making a comeback now. So a lot of people are trying to be more natural and run everything through the refugium. So we talked about earlier about using Chaeto. Now, the other almost kind of hot filtration one I'd say in the past year or two has been algae turf scrubbers. And that's one I've seen pop up a lot. And, I know a handful of people with them. Thought about building one, hasn't happened yet. But they work similar to an extent where, in general, they grow almost like a hair algae, basically. Because it's a very basic, fast-growing type of algae in the turf scrubber. So that's going to absorb a bunch of nutrients in your tank and kind of outcompete it.
Yes. But they're good at removing certain types of excess nutrients. we noticed that a lot of the turf scrubber actually pulls out a lot more PO4
Mhm.
than the Kato. It doesn't pull it out in a balance, at a balanced ratio.
Oh,
Even
interesting.
though it does pull out some nitrates, it's better at pulling out the PO4, which is one of the reasons why in the later part,
Mhm.
the people that are utilizing the turf scrubbers are still seeing high nitrate levels.
Yeah. Where do you find Chato's more on the nitrate side? Or is it more balanced in your experience?
Also ammonia. It pulled. Sorry about that.
Yeah, no problem. Yeah, so
Yeah, hello?
yeah, figures. Yeah, so the turf scrubber is one thing that I actually haven't tried yet. I bought a bunch of bulkheads and some acrylic to build one, but it hasn't happened yet. It may ended up just going back to the standard issue refugium on the next sump, but we'll see.
Yeah, sorry about that.
Yep, no problem.
Whereas, yeah, what was I saying?
You were saying about the Chato pulling out the phosphate nitrate more on an even keel. Is it gone again?
Yeah, I think so. Sorry, I got a phone call too. Cut out for 1 second.
I think what it is, Dev, is just understanding what things do and then balancing it. Because nothing wrong with using a turf scrubber at all, but just understand what it does and how it works. Then with the excess nitrate, then put something else in place for that. As a backup.
Exactly. But understand that if you depreciate one or the other, phosphate or nitrate, that you're going to cause an imbalance in the system as well again.
Yeah.
So
yeah, you got to equal the two things.
Yeah. So that's one of the reasons why when it comes down to feeding, also the input of nutrients into your system, you have to balance that as well. Feed some pellets, feed some flakes, and then feed the frozen myces. Once again, going between the herbivores and the omnivores and also the carnivores. You have to have a balance in that because in order to have a stable ecosystem, you need to be able to raise the phosphates and raise the nitrates.
Yep.
At pretty much the same rate, or what the Redfield ratio would call 14:1. But then, kind of like what Nick was alluding to earlier, carbon dosing. That's also part of the Redfield ratio as well, and a lot of people forget about that. So the Redfield ratio for the carbon, for the carbon source, vinegar, sugar, vitamin C, vodka, the methanols and ethanols.
Marine pills and pellets as well. That's what they were for.
Oh, absolutely. That too, and some of the petroleum products, the petroleum cubes that you also put in before. That was the carbon source. Our systems are typically carbon deficient when it comes down to that, and I'm not talking about carbon dioxide deficient, but carbon utilizable form in the biological utilization of it for the bacteria. We are deficient in carbon sourcing, so that's one of the reasons for the dosing of the vodka, the VSP method, the vitamin C method, and a lot of people are going back to it. That's one of the reasons why no pucks took off so well.
Yep.
That's one of the reasons why all these other all these other additives that added the carbon source back caused their systems to actually bloom again.
So okay.
Carbon shortage.
So on that note, with the carbon dosing, so you could essentially be doing without knowing it from Chato die-off, could be dosing some of that back. You could be using like Red Sea's no-pox. You could be using vinegar, vodka. I'm not a big fan of them, but you can be using like the bio balls, whatever they're called.
Yeah, the pellets.
Yeah, little pellets, bio pellets. Thank you.
Pills.
Yeah, so I mean, those are all different ways of creating carbon dosing. And carbon dosing is essentially feeding the bacteria. So you're using the carbon to feed the bacteria and build up your bacteria so it can handle more of a load on your system. It's kind of a general overview.
Yep. That's one of the reasons why they put the bio pellets, right before the friggin' skimmer. Once again, trying to extract the excess nutrients at the source, the source of exit. So that would be your skimmer. So all the friggin' bacteria that's dying off goes to the skimmer, gets floated out, and gets skimmed off.
Yep. No.
So that way it doesn't circulate in your system again.
Now, a note on that, I've seen other people have issues from not directing the output of like their biopellets to their skimmer because
Oh yeah,
it's breaking down all that nasty stuff and you're just releasing back to your tank. So if you are doing that, you want to make sure you do it right in front of the skimmer so that it can be sucked in and react and skimmed out right away. I've seen
The other
that more
thing
than
that you
once.
can get in the other thing you can get in some of the pills and pellets as well, depending on what brand you use, is that they also put binders and things into the product.
Mm-hmm.
So that's another reason for doing that, is to extract those binders and things that as they're leaching out of the reactor.
Yep. Have you ever used biopellets before?
Yeah.
I never have.
The one that I've used that I really like actually is one that we can't get in the UK anymore, but you guys can get it. It's the Dr. Tim's
Didn't know they made one.
pills. Yeah. Now, if you look into that product, the reason that's a particularly good one in my mind, in my opinion, is because it's a natural. It's made from, I believe, corn, and it's 100%. They don't. Yeah, Tim doesn't use any binders or anything in it, so it's a raw carbon source. So I found it very effective with none of the negatives that I found with some of the other ones.
Correct. The next step is it breaks down into ethanol on bacterial utilization or digestion, and then from.
So quick question in the chat. Actually, two of them all. First one, do you need to use bioballs if you're using no-pox? Essentially, they're doing a similar thing. So I don't know if I'd want to use bioballs and no-pox at the same time because they're both essentially carbon dosing, so you could very likely overdo it. With carbon dosing, it's better to go slow and slowly ease into it. Doing too much can cause trouble in your tank.
Yep, it can wreak havoc.
Yep.
So typically we find a point to where it stabilizes, your nitrates and your phosphates don't rise anymore. And we slightly increase it to decrease it to the point where we need to be, and then we back off on it. So I mean that's how we tune our carbon dosing loop.
Yeah. You want to find just enough without using too much. Yep.
Correct.
Dev, I'm just wondering if you know about the different types of bacteria as well, and the way that they consume or utilize the nitrates. Do you know that there's some of the bacteria that we, when you're using pills and pellets and things like that, they actually absorb the nitrate into its membrane.
Yep.
So that's one of the reasons for exporting the actual bacteria itself.
I forget the names. Yeah, I forget the names of them, but one of them
it'll release it back.
Yeah, one of them will absorb it, and it'll turn into a different type of bacteria strain. I forget the names of them. Good old question for crew. Thank you. That's familiar. One in the chat for you. Ash is asking, what's the difference between Miracle Mud and I think it was Fiji Mud? Miracle Mud. Oh, Miracle Mud and Mineral Mud.
Oh. Let me see.
Copycat
the way that
you mean?
the way that I would compare it is Mineral Mud is Miracle Mud after a year and a half, maybe 2 years.
So it's a similar product without all the extra good stuff infused
so
into it.
It's depleted already, and it's also very, very fine and very, very dirty.
Okay.
I would say when I've opened up the Mineral Mud bottle, it was slightly damp. You could see humidity in there. And when I opened it up, my God, it stunk up my entire friggin' fish room.
Nice.
With hydrogen sulfide. I mean, it was like rotten egg. So why would I want to put that in? Do you know what I'm saying? So I was very, very leery of it, and I just ended up chucking the bottle. that was long before. Let's see. I want to say long before I started speaking for Miracle Mud.
Okay.
So I was utilizing Miracle Mud at that time. Lang, of course, being my mentor, I was utilizing the products that he was producing.
Yeah.
So I became a super user in my reefing systems, utilizing the ecosystem products, which included GFO. They had their own ecosystem carbon filtration media. They also had a lot of other stuff. they utilized GFO before GFO became popular.
Yeah.
And it came out with it in the late 90s,
Mm-hmm.
early 2000s. So, you know, once again, you know, who was leading who? You know, back then they laughed at GFO and said, well, you're just going to be leaching metals back into your system. Because no, but it removes phosphates.
Mm-hmm.
and there was a big hubbub about that as well. But then now, after time, you know, people are saying, well, let's go back and find out what actually worked. And that's when the friggin' GFO, and that's when BRS picked it up, the GFO line. And then once again, it became popular.
Mm-hmm.
Do you know what I'm saying? It was already, I would like to say that Lang spearheaded that one, and he got shut down and laughed out of the, laughed out of the auditorium, basically saying, yeah, GFO removes phosphates. And yeah, that was, I want to say late 90s. People didn't want to hear about GFO.
Mm-hmm.
And they were too scared of metals. They were too scared of everything. You know, everything was a knee-jerk reaction when you wanted to add it to the system.
Mm-hmm.
At that time,
It's a bit like the micro bubbling, right? Everyone was going,
oh, absolutely.
You want to put micro bubbles into your tank? I thought that was bad to have bubbles in your tank, you know?
That was the whole attitude as well. It's like, you're going to put rust back into your system.
Mm-hmm.
Yeah.
And, you know, that was the whole attitude back in the 90s. You know, and that was the same, the same reaction. But then for some reason, when BRS.
So, okay, just on that one, a couple questions that are popped up in the chat. So when you're asking, can you use miracle mud as a substrate? Yes, you definitely can. Can you mix it? Yes, you can. I've seen lots of people do a layer of it and then do their substrate on top of it. And someone else was asking, aren't you supposed to change it out regularly? Personally,
No.
I don't think you have to take it out. I would just add a bit more just to replace some of those elements that may be used up or fully pulled out of it. But I don't think there's any reason to remove it. It's just another, like your sand. I mean, it's in there, right? It's just another substrate particles in there. And then once it's absorbed all the elements or nutrients or trace elements out of it, the main reason to replace or add more is just to refresh your little battery bank of elements.
Absolutely. And there's also another product from Ecosystem Aquarium that's called Reef Solutions, and that puts a lot of the stuff back in that the Miracle Mud actually leaches out as well.
Mm-hmm.
So basically,
It's like liquid
mud.
Yeah. Nice.
So yeah, a lot of the elements that we engineered back into Miracle Mud, you know, we captured it into what we call Reef Solutions,
Mm-hmm.
and also we had a little bit of a crossover from Reef Solutions to what we call Total Nutrition.
Mm-hmm.
Total Nutrition, which is a coral food, that also has a lot of dissolved nutrients and vitamins and just basically the plethora of all the freaking amino acids as well.
Mm-hmm.
So Total Nutrition, it's a relatively new product. It came out in 2016. Out of the entire friggin' ecosystem line. The original ecosystem line came out in 95, 96.
Mm-hmm.
And so, I mean, this line, this ecosystem aquarium line, has been around for a long time already.
Yep, definitely has.
So the thing for me, Dev, is what we're talking about is you can see with filtration now from talking about, the original sort of undergravel filters and things like that. You've kind of got three elements to filtration, right? You've got mechanical export, you've got bacterial or biological consumption and breakdown, and then you've also got
The
stuff
macroalgae.
adding back in as well.
Yep.
Yeah, like macroalgae and stuff, but you've also got replenishment through your filtration. Because a lot of people think filtration simply as removing, removing waste or getting rid of unwanteds. But
Yep.
at the same time, you've got to consider the element of your filtration that's adding back into the system. And that's a key component of filtration.
Mm-hmm.
So that's why Cruz was saying earlier about if you only think of filtration as removing, then you can actually do your system some unbalance and some, injustice, because you're not putting back in, you're just stripping out. And that's what you've got to be careful of when you're considering, your sump design and your filtration methods.
Yep. Okay, so Ash was asking two questions. One says, how much flow do you need? And the other says, is it okay to put a tray in your refugium? Yeah, so the refugium is where most people will put miracle mud. Under my frag rack, I think I have like 5 or 6 trays of it underneath there. One quick tip for that too,
Flow
if
for
you're,
me is a difficult one.
yeah, flow is difficult to quantify. Um,
Yes.
because there's many different types of flow, right? I mean, there's a jet stream of flow or you have very broad, subtle water movement. One might be this high pressure stream, but it's not moving a ton of water, where the other could be moving the whole tank back and forth. Or, if you have Miracle Mud Reactor, you're pushing it through it. So there's a lot of different ways to kind of quantify flow. It's kind of a tricky one.
If you're talking
Yeah.
about like flow from display to sumps, what I call turnover flow.
Mm-hmm.
So the flow rate that's going from your display to your sump and then back to your display. Generally, I kind of find with algae-based systems, you want to be anywhere above 5 times turnover. So 7.5, 10 times turnover works really well.
Exactly. Not enough to stir
With
up the mud, but enough to
yeah,
I mean, the macroalgae itself acts as a damper, with flow, and it actually baffles a lot of the turbulent flow and actually laminarizes,
Mm-hmm.
the flow as a column. So, I mean, that's one of the reasons why when you're actually taking a look at a Cato refugium, you're noticing that, the top of the water where the Cato is very, very still. It's almost mirror-like. It baffles all that flow. Typically, you don't have a lot of tumbling water. You don't have a lot of current, a lot of eddies. It's very, very laminar flow at that point.
Mm-hmm.
It already baffles it.
Yeah.
Like
Just quickly want to address something that Michael was saying. He said he had a biopellet reactor with water and just kind of on standby for backup. I've seen biopellets cause havoc on a tank after an extended power outage. So if there was your biopellet reactor sitting for an extended period, like, even like a day, like half a day, I would dump that water out, make sure you put fresh water through it, because that can get all kinds of nasty stuff breaking down in there you don't want to introduce into your tank.
Biopellets is like, it's a difficult one because people sometimes see equipment and methods as a solution. The way I use a lot of products like carbon, GFO, I think is like yourself, Dev, with the GFO, is just to remove the drift of the phosphate levels.
Mm-hmm.
And the same thing with the biopellets. I'll use biopellets sometimes, but I'll use it to kind of stop a drift. I wouldn't run a system and run pellets on it constantly.
Mm-hmm.
It's another tool in the toolbox just to do a job.
Yep.
And then I'd take it off and then, run the system. And if something drift, then I'd get the correct tool out of the toolbox and use it and then put it back in the toolbox.
Now,
So
I have
don't rely on things too much.
Yeah, I have a slightly different strategy with that, which that's a very good way to do it. Like, technically, when I do stuff like that, I'll leave it on, but I'll just use a very slow flow. So you're not, using a ton of it. You're just using a tiny bit of it constantly.
Yeah, exactly.
Yeah.
Like you only like the GFO. I only use maybe a tablespoon to 2 tablespoons because the drift that I'm talking about is a very small drift. You don't let it accumulate, so you need to whack a lot of stuff on it. And same with the pills. When you look at the dosage levels, I'm sometimes using like less than a quarter of the dosage levels because I'm only attacking a very slight drift rather than letting it accumulate to I need to really whack stuff on it. Because then your system's already out of balance by that time.
So another slightly interesting one on the filtration, the sumps. Like, I know there's one school of mind which will literally use a tank with nothing. Like, it's all same water level. You just have all your stuff. It's basically just a container for extra water and house your equipment. There's another school of thought,
baffle sumps.
yeah, which will use a ton of baffles and have these crazy chambers and direct your water through a certain path. So, I mean, I've always used baffles because partially just, if I have a refugium or something, I want to separate that algae and the light from touching the other stuff. And I've always sectioned mine off. I've never done a baffleless one, but Nick, I know like in the UK and a lot of you guys have done that before.
Yeah, I mean, you got to look at the history of sumps. This is the thing, like, either because we're too old or we're lucky, I don't know. But, we were around when sumps came into fashion, came in. And the reason we baffled them out was because at that time we were using things like deep sand beds that needed very slow contact time. So everything was compartmentalized. Yeah. But now in the modern time, I'd be more than happy to have a baffle of some. I'd still keep, a baffle in place for the return pump and maybe for the skimmer height. But that can even be done different ways now with skimmer tables and egg crate.
Yeah.
So is that really needed, to keep that constant height? I don't know. Also, things like auto top-offs. It's easier to auto top-off just your return chamber than a whole sump.
Yeah.
Because imagine a 2 millimeter or 3 millimeter drop of water in a return chamber compared to a 5 foot sump. There's a big difference in terms of amount of displacement, right? Yep. So, but that being said, you look at the way I'm running my system now. I use reactors a lot. I use reactors for miracle mud. I use reactors for the algae. I use reactors for the filter media, and what that gives me is flexibility because I can run a fast flow through my sump, which another reason for the fast flow we're talking about for the algae is also turbulence. Turbulence increases oxygen saturation in water. So it means that the water is well oxygenated, which benefits everything, So what that means is I can run fast turbulent water through my sump system, but the areas I want very slow flow and good contact time through the miracle mud, through my bacterial filtration, because I want more anaerobic autotrophic bacteria in there. So I can control that separately to the flow of my sump. So for me, reactors are fantastic. So if I'm using my compartmentation as in the reactor as my compartmentation for individual filter medias, etc., why do I need baffles in my sump?
Yeah, well, that's fair. I guess it's technically just a compartment for water flow.
Exactly. So what I'm doing is, instead of using the compartments of the baffle for the media, I'm putting it in a controlled flow tube. That's my compartment. So the sump itself is, like you said, it's just a box for me to put those reactors in.
Yeah.
And extra water volume.
Now, yeah, no, that's a good way, a different way of thinking of it, but yeah, it's true. I just had another point I want to bring up. I completely just lost it.
Well, I mean, there was also the fluidized bed, which was utilizing the deep sand bed method, but pumping water through it at a steady flow. Another.
Telegram, Michael Balsley, thank you so much. Much appreciated.
Yeah, in the mechanical filtration as well as the the anaerobic and aerobic side of the digestion and filtration. So once again, you're increasing surface area for the biological filtration, which is bacteria. Well, then you're also utilizing sand particulates to filter out.
Now that's
chunks and pieces.
That's essentially what they do on a pool too, right? Like they have those big pool filter sands, and they basically just pump the water through a giant sand bed.
Yep, correct.
Yeah, we still use those. We use those in commercial systems for fish stocking and coral bays and stuff. I've got them down at my unit ready to go on my fish stocking, so I'll be using those.
So once again, old school methodology, but utilizing the new pumping mechanisms, pump controls, utilizing DC pumps, utilizing speed control pumps. Instead of utilizing bypass valves now, because pumps used to be one set speed only.
Yeah.
We didn't have the DC pumps until recently. So yeah, being able to actually control it at the pump instead of utilizing a bypass, to control the valves to control the flow and the flow rate and so on and so forth. We now can actually control the flow at the pump itself.
Have you ever looked into that, Dev, for a sand bed filter?
A sand bed filter?
Yeah, have you ever looked into that?
I've never used one, but I've definitely seen a bunch of them.
I'll tell you what, that'd be a good thing for you to have a look at because they're very efficient.
Yeah.
Very efficient.
And then
the surface
you guys
area
remember
of the sand.
And then you guys remember the old diatom filters too, right?
Mm-hmm. No, I've never used one, but tell me more.
Yeah. Well, I mean, yeah, the vortex. It's called the vortex diatom filter.
Mm-hmm.
Once again, back in the day, that was our polishing filter. Nowadays, we have the Magnum hang on the back by Marineland, as close as we could get to a diatomaceous earth filtration unit. Um, you know, they used to utilize it a lot, and the pump would actually, take in the water and then it'll spin out. And then as the diatomaceous earth packs in, it makes a very, 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 very fine filtration unit.
Mm-hmm.
And it actually pulls out a lot of the organics, a lot of the particulates, and actually polishes our water. That was how we did it before.
Mm-hmm.
You're going back to
along with this.
Going way back.
You're going back to when they used to crank the car by putting the thing in the front of the engine and winding it. There you go. in hobby terms, it's like that.
yes. So you get the vortex filtration units, and they're very, 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 very hard to find, but they were very good at doing what they needed to do.
Mm-hmm.
So once again, you have the hang-on back. What is it called? The Magnum filtration units. They're decent for the hobby, but they weren't as robust as the vortex. The vortex were the tanks to polish the filters, to polish the water all the time.
So I've always used
and you would turn it on.
Yeah, like I've always used filter socks just because I love how they polish your water so clear, but at the same time they are a bit of a pain, so I'm not gonna lie, I'm a bit tempted to take them off some days. But they do give you that crystal clear water. But I also have ozone, which also does, clears it quite a bit as well, so floating fish.
Absolutely. So
Mm-hmm.
Yep. Oh yeah, it's very, very funny how some filtration systems have gone to the wayside. Vortex, saw that there was really, really not that much money left in the product anymore after it went retail.
Mm-hmm.
You know what I'm saying? But I want to say for a good 2-3 decades, they were doing fine, cost wise, and then started getting replacement units that got rid of the friggin' the glass housing, that got rid of the metal pumps, the metal pumps, and replaced them with plastic ones.
Mm-hmm.
And you lost a lot of efficiency, and but at the same time, the price point went down when we went towards plastic pumps. You remember back in the day where we're utilizing the Pan Worlds and the Iwaki pumps and all the external pumps. Those were a pain in the butt because we had more leaks. It was also very, very hot. Those pumps ran very hot. Sorry, I'm going way back.
No, I'm just reading.
I just lost him for a sec. Laughing, reading all the comments. My old fish store uses a diatom filter, had it on a cart, and moved it from tank to tank. Huh, crazy. Yeah, some of these were definitely before my day of reefing. I've heard of them, but I've never used a lot of these older systems.
Sorry, I was just laughing at Dave when he was putting on
the diatom filter.
My old local fish shop used to, he moved it from tank to tank on a cart. I just thought
that
was
was
funny.
we used to do that.
Did you?
Yeah, just to polish all our filters. Yeah, to polish all our water.
Mobile filtration.
Oh, that's awesome.
Yes. Yes.
But the interesting thing, Dev, like when we're talking about old school filtration compared to more modern filtration, if you look at in terms of bacterial side of things, whether it's a plenum, whether it's a shower filter, a trickle wet and dry, biopearls, pellets, all those things, the main thing for it was the bacteria. Was housing, generating, populating, cultivating bacteria, right?
Now, at the end of the day, most of these quote unquote live filtration methods we're using, it's all to host bacteria, right? Either to grow it or to host it or to help it thrive.
Yeah, exactly. Carbon dosing, all these things is all towards the bacteria.
So other than physically removing it through, like, say, a filter stock that you actually change every few days, or something like a roller mat that catches all those particles, if you're not physically removing it, it's the bacteria that's going to break it down instead.
Yeah. Now, what's weird for me, Dev, this is the point I want to make, is
Mm-hmm.
live rock. I remember the days when we used to use what we called ocean rock, which was very dense, dry rock.
Mm-hmm.
And there was lots of arguments about using live rock. Then more modern, more recently, if you told somebody not to use live rock, to use dry rock, it'd be, oh no, because I need the bacteria, right?
Mm-hmm.
But now we've got products like ATM, Fritz, Dr. Tim's, bacteria in a bottle,
Mm-hmm.
that you can just add bacteria. So all of these cultivation methods of filtration, you can just add the bacteria.
Yeah.
But when that product came out and people were saying, don't do a 6-8 week cycle and just add bacteria, what
Mm-hmm.
happened? Everyone was saying, oh no, that's not natural. How is that going to work? And when we're saying, well, rather than carbon dose and do all of these things, why not just, they're going, will that work?
Mm-hmm.
So even now we're seeing another kind of, thing that you can do to actually, if your filters aren't working very well, will boost the bacteria by, instead of trying to cultivate it and do things to make it grow, just put it in your tank.
Mm-hmm.
But yet, even now, after how many years and generations of reef keeping or fish keeping in general that have been designed to breed, cultivate, feed the bacteria, and we're saying, well, now you can buy it in a bottle that you can just add it. Even now, people are saying, oh, that's crazy talk.
Mm-hmm.
And that's
Which,
today.
okay,
That's what we're going through now.
exactly. So on that note, my first saltwater tank, I bought quote unquote live rock. I mean, not straight from the ocean, but from
Uh-huh.
another reefer that literally was selling out of a giant tank with a couple fish in it. Like to start
Mm-hmm.
my first tank, because everyone's impatient. No one wants to wait a month or two before they start their tank. So I started with pretty much all live rock. Second tank, I use a little bit of that, but boiled Dr. Tim's, and I mean, it's amazing how much quicker we can start a tank these days using like jump starting it by adding these bacteria rather than letting it slowly build naturally.
But you'll just go onto Facebook groups and forums and things and say that, and
Mm-hmm.
you'll get a divide between people saying, oh, no, nothing good happens fast, and you need patience, and that's not natural. We need to do
Yeah.
it the natural way.
Well,
Yeah.
But
Well, the
what is the
funny thing
natural
is
way?
that
You're
yeah,
you're
the natural way
cultivating
is
bacteria.
yeah,
bacteria is
and the
natural.
and
It's
it's
alive.
funny that
Mm-hmm.
it's funny that they would say natural is because once again it's in a glass box.
Mm-hmm.
Yeah.
There's nothing natural about a glass box holding corals,
Mm-hmm.
but you're
Exactly.
trying to replicate it.
Sure.
You're trying to replicate it, as close to nature as possible. I think is what they're trying to say, but they keep on saying, well, it's not natural, it's not natural. But they would throw in a half digested freaking raw piece of shrimp, and they don't even know what bacteria is in there.
Mm-hmm.
Do you know what I'm saying? Because raw shrimp, I mean, you could have like a healthy population of shrimp, and you could have a very, very sickly population of shrimp.
Yep.
So it depends on where you get your shrimp from, and depending on that shrimp, you're cultivating bacterial strains that you don't know
Mm-hmm.
that you truly have or not have.
I mean, at least if you dose it, you know which bacteria strain you're actually adding to it. So, I mean, that's one kind of benefit. It's ones that are tested, and whatever one the bottle says, specific ones you've added it. If you research, which bacteria it's going to break down and kind of what it is. I mean, most of them are like the different denitrifying, but at least you're adding the good ones, not necessarily just random. Who knows what's going to show up on the dead shrimp?
Yeah, because what you also get is you get dominant bacteria.
Mm-hmm.
So Dr. Tim's do a product called EcoBalance, for example. Um, you know about Vibrio in corals?
Semi.
Yep, Vibrio. Have
Vibrio?
you also have what is that other one? Legionnaires. You have Legionnaires in there as well.
Yeah.
You also have
So
Streptococcus bacterium. Yeah.
so with some of the bacteria, if you dose it, it becomes the dominant bacteria
Mm-hmm.
and then eradicates the Vibrio and some of the other bacteria. So bacteria dosing actually, for me, people need to look into it more because you can control the bacteria in your
The
system as well.
population.
Exactly.
Mm-hmm. Now,
When
some
you
of those
carbon dose,
And
which
basically it
bacteria are
outcomes
you feeding when you carbon dose? You don't know.
probably most of them.
Exactly.
Mm-hmm.
So what if you've got an imbalance in your bacteria?
Well, I mean, to an extent, that could almost be Russian roulette on if it's, more good bacteria or potentially harmful ones in your tank.
Exactly. So by dosing cultivated bacteria in a
Yeah, you
product, in a
maintain the
bottle,
population. Yep, you maintain
you're
the
maintaining
population.
the correct populations. Exactly.
Now, some of those other ones, like you're saying, like those almost like top up for revive your good bacteria cultures. Have you guys used
Hmm.
much of those? I've never tried them other than using like the start your cycle ones, like the one and
Yes,
only and those type.
we continue. We continue dosing the we we continue dosing it quarterly.
Hmm.
To make sure that we have the right population. We're inducing a small, controlled bacterial bloom as well by overdosing carbon. The carbon source with a little
Hmm.
bit of vodka,
Yeah.
sugar.
Now, just a
Anyway,
note
and the
on
thing
that.
is that
Oh, quick note on that one, just because I've made that mistake. If you are ever go down the
yeah,
vodka or any type of carbon dosing, go very, very slow. Like I know at one point, I dosed, I went a little too fast with it, and like my yellow tang, he had all kinds of some weird orange blotchy spots from it. And I stopped vodka dosing, stopped carbon dosing, and on away. So same thing. It's probably from going too quick. So like anything, like it's better to go slow than just ease yourself into it very slowly till your tank
yeah,
adapts.
So that's where I doubt.
correct, and that's what.
That's why I now have the argument of: is it better to carbon dose,
Hmm.
or is it better to buy a bottle of ATM Outbreak and add a cap full of that every
Hmm.
other day?
Yep, for say a week.
Yeah,
Hmm.
Just to
because
get the population back up.
you're not getting the risks that you're getting with carbon dosing.
Correct.
Hmm.
And the thing is that what people forget is that the bacteria also utilizes a lot of oxygen.
Mm-hmm.
It in itself is a bioload. It is like an organism. Even though it's multicellular, it's still an organism and it's utilizing oxygen. So while you're doing the bacterial population increase, you also have to aerate to keep
Hmm.
sure,
Mm-hmm.
to make sure that the oxygen levels, and
So
that's one of the reasons for the microbubbling
yeah,
as well,
so
utilizing fresh air.
So on that note with the microbubbling, that's something that I've been doing for quite a while now, and it turns on every night when the lights go off. My nano bubbling turns on, and it runs until morning till the lights come off. So I know I've explained it this way before, but easiest way that I try and explain to people is basically like turning your tank into a big skimmer. All those little micro pinhead size bubbles swirl around your tank, and they attach to organics. They'll bring it to the surface, where it can go down your overflow and into your sump and be filtered out. That's kind of the easiest
Correct.
way that I found to try and explain to
Yep.
people.
Yep. It's
Now,
a detritus transport mechanism. It's a mechanical.
mhm, yeah, so basically it tracks them and picks it up and takes them for a ride. Now, I know some
Yep.
people go
Absolutely.
skimmerless. Now, if you're on one aspect, like for me, I like a silent tank. I make sure, all my water drops are
Mm-hmm.
less than an inch, so it's not going to create a big waterfall sound and keeps my tank super quiet. Now, if you're doing that and skimmerless, you could be potentially depriving your tank of oxygen. So a skimmer is probably the most efficient way to get oxygen in your tank. Now, micro bubbling is another great way too. Now, one thing a lot of people do is have
Yep.
an air pump in their stand, but ideally you want to be drawing air from outside of your stand because you're just going to be more
Mm-hmm.
fresh air. Now, if you want to go to the next level up, if you can get outside air and bring it into your house, by cracking a window or maybe you have a little airline you sneak out somewhere, and that can make a big difference too of getting more fresh air into your tank. Some houses,
Absolutely.
especially,
And you notice, yeah, you notice when you actually utilize fresh air from outside,
hmm
Devin, that your pH started stabilizing, right?
yeah,
And so did your alkalinity and everything else.
yeah, I probably got
Everything else
about
started falling into.
a 0.1 boost in my pH, I'd say. Now, I'm also restricting my airline because I didn't want to drill a new
Mm-hmm.
hole, and I was able to sneak out like a 6 millimeter quarter inch size thing. So basically, I used the RODI tubing and I ran that outside, and so that it's like 4 millimeters probably. So super tiny, super restrictive. But even that alone, on just one of the silencer ports on my skimmer, raised about 0.1. So it did have a nice positive boost to it.
Excellent.
Yeah, so the fresh air definitely helps.
Excellent. Yep. And you notice that the fresh air also attracts to the detritus and actually creates a nicer foam head as well,
Hmm.
right?
Yep.
Mechanically. Yep. There's something about utilizing fresh air versus carbon
Hmm.
laden air or laden air, increases the foam head.
So, like one thing, like in an older house, it doesn't seem to be much of an issue because you have more little cracks and gaps and stuff flowing. But if you have a very well insulated house, it's great for keeping your house warm, but you're also not getting in much fresh air from outside. And if you have, a big family, lots of pets, like they're all this carbon dioxide producing machines, and all that water agitation, everything is absorbing the outside air into it. So you're going to be absorbing more carbon dioxide in your tank and not necessarily as much fresh air.
Correct. And people forget about this too. The macroalgae also release CO2 during the dark cycle. When you're doing a counter cycle.
Yep.
And I mean, you're thinking about it this way. As much oxygen as it's trying to produce. When the lights are off, it's also producing carbon dioxide. So it's now another carbon dioxide, adding machine to your system. But then there's also the difference with the lights. The lights also cause what we call photolysis, which is basically breaking the water molecule down and actually bringing up that oxygen.
Yep.
The oxygen molecule as well. And that's one of the reasons why when we have a good light source, typically we've seen it in halides, very, very predominantly, and also T5s, is that the pH would go up when the lights are on, especially in the high light systems.
Oh yeah, there's definitely a big swing once the lights turn on. Now,
exactly. So I mean, that's go ahead.
Oh, so one thing I've done on my tank, so I have the Chaeto reactor, which runs reverse light cycle, and I also have a frag section, so I have my frags and my sump in one of the chambers. And that same thing, I run that on reverse light cycle to my main tank. So I have, corals growing in there, so that really actually helped balance out the pH quite a bit too.
Absolutely.
Yep.
So yeah, I mean, there's a lot of reasons why regimens or light cycles or this and that. Once again, these things didn't happen, at the beginning of the hobby. They were developed as time went on. And one of the things that we did find out is the caulerpas and stuff like that, they needed a dark cycle. The more simpler macroalgae, such as the bottlebrush and also the Chaetomorpha, have a true structure, mat of long, skinny things. They don't need a dark cycle.
So
to run counter cycle utilizing the Chaeto.
Yeah, I've experimented with different lighting periods with Chaeto, and I don't think I've noticed like a huge difference either way of giving it 12 hours versus 16 to 20 hours. So thanks for confirming that.
Not a problem. So yeah, the Chaeto, we run it in our systems 24/7, and we have a huge Chaeto sump with Miracle Mud in it as well.
So do you find a difference running it 24/7 versus just at night? Because would it almost boost your pH potentially too high if you're running that plus your display tank, and then at night you'd still have a drop versus running it reverse? Or is there just, it's always growing, it's always sucking up the nasties? Okay.
It's constantly sucking up the nasties, the CO2. We have a slight dip, but it's usually 0.02.
Okay.
Not 0.2, but 0.02.
Okay.
Swing in pH.
Yeah.
So, I mean, that's pretty darn stable. You know what I'm saying?
Yeah, that's super
Especially
stable.
in a large system of 1,500 gallons. 1,500 plus.
Now, how large would you say your refugium section is relative to your display tank?
Oh.
I always think you need to look. You always need to look around 10, at least 10%. I would say.
Minimally 10%, but ours is running at I want to say close to about 60% size.
What size, sorry?
60.
Okay. Yeah, so you got a pretty big size reactor in there. So I'm just looking at my tank, and I get quite like a decent swing. So my pH goes from about the last 24 hours, so about 8.09 to 8.25, and I cracked the window today, so now it's up to 8.21. So gets a decent swing. But yeah, before I sucked in fresh air from outside, I struggled to get my pH above 8. Now, looking at my
Wow.
apex for the past week or so, the minimum is 8.05 and the max is 8.25. So it just shows how
Yeah.
much of a difference adding fresh air can really make. Because it was literally
Mhm.
like I'd say 7.8 to 7.98 or something was my range prior to giving it a bit of fresh air into the tank. And now 8.05 is my lowest, so it's been a pretty big jump over time.
Yeah.
It's strange, isn't it? Because you always think of buying products, buying equipment as making improvements, but even
Mhm.
something like that, you don't realize how much of an improvement it can make, right?
Yeah. And the thing that amazed me too is I have such a tiny restrictive. I'm using an RODI, probably about 15 feet of it to draw that air from outside, and it still makes that big of a difference, which is pretty awesome.
Yeah. Imagine
Mhm.
if you got a compressed oxygen cylinder and used that, so you just got pure oxygen.
Mhm. Yeah.
What would that do?
No kidding, eh?
Or you could even or you could even enrich it,
Mhm.
intake air, where
Inject.
you're
Yeah.
bleeding in a little bit of oxygen as you're taking in some of the environmental air as well. And all you're doing is just raising up the freaking oxygen levels back up again,
Yeah, the oxygen content
by
of the
bleeding
air.
it in. Yeah, so you
Mhm.
don't need much pressure. You don't need much, you don't need a huge volume of oxygen, going in, going back into the skimmer and or to the, to the air intake pump.
A
Mhm.
lot
But
like the freshwater guys do with the CO2, right?
Mhm.
yeah, yep,
It'd be
they just bleed it in.
It'd be an interesting experiment. Yeah, like back in my plant to tank days, same thing. I had my compressed, my 10-gallon CO2 underneath the cabinet and, constantly doing micro bubbles of CO2 into the tank.
Mm-hmm. I mean, it's only the same equipment, a regulator, a cylinder.
Mhm.
Yep. Thing as a calcium reactor, that's where they got that idea from.
Oh, really?
Controlling it off of,
Huh.
freaking Milwaukee SMS 122, I
You
believe,
betcha. That's
122
exactly what I used
CO2.
to have.
Same here. I mean,
Mhm.
you remember it was green. It was green before. Now it's gray
Yeah.
and horizontal.
Yep.
Um, I don't like the new layout,
Yeah. I, I,
personally.
s- I actually swapped it. My newer one is a super tiny, uses a DC solenoid. And I think it's
Uh,
American Marine Pinpoint, I think. But yeah, it's very tiny, all in one little reactor solenoid. And I like the idea of DC rather than AC because in theory it should be less likely to ever stick. Less heat,
yep,
less stuff. So,
absolutely.
but that being said, my calcium reactor is sitting in the shed, but one of these days I'll get it back out again.
It's okay. It's taking a break.
Yeah, exactly. Takes up a lot of space in the stands where my frags are now, where the
Yeah,
calcium
I
reactor used
mean,
to live.
imagine reversing it and, once again, kind of like what Nick was saying, is actually utilizing a freaking oxygen tank instead,
Hmm.
to enrich it, or an oxygen concentrator,
Yeah.
because that's all you need. Just utilizing an oxygen concentrator and then sucking it through that.
Mm-hmm.
You could actually increase your freaking overall oxygen levels in your tank.
Whew, those aren't
And
cheap.
once again, yeah, exactly. And then you put that enrichment in there, and you
Hmm.
could actually, what we call overclocking your system, is basically keeping your oxygen levels so high that you'd be able to actually keep more fish in the system.
Yeah.
You know what I'm saying?
Now,
Um,
do you think the higher oxygen concentration would have any difference on coral growth?
oh, it has.
Yeah.
We've, I mean, you're talking about overall density.
Hmm.
Now you're able to have, tighter clustering of the corals, in the growth structure, because now it's no longer fighting,
Hmm.
fighting its
Mm-hmm.
neighbor for oxygen, because now the oxygen is readily available in the laminar flow in between the freaking branches.
Yeah.
You know, they don't have to fight the other, the other branches for oxygen intake.
Hmm.
Now you're getting tighter clusters, you're getting, thicker branches, because now it could actually sustain a thicker organism and, more dense growth patterns in the organism as well.
Hmm.
And that's also the benefit of the microbubbling, is that the bubbles actually go in between the branches as it's, getting blown around with the, with the wave maker or whatnot,
Hmm.
and it's actually increasing and enhancing the flow. Very similar to, the RFG nozzles as well,
Hmm.
is that it increases the flow, the turbulence in between what we call micro laminar flow around the freaking coral branches
Yeah.
themselves.
Hmm.
So by utilizing the bubbles, you're increasing your flow patterns. And you've seen it right before lights out. You notice that freaking bubbles,
Yeah, all the bubbles wrapping around it all. Yeah, they're asking about boron. I've never used boron, so I can't really comment on that one.
the bubbles have a volume, so you're not only pushing water, but you're also pushing the air. So you've increased your overall dynamics. You're not only pushing water, but you're also pushing the bubbles that are pushing the water. So it's kind of like pool or billiards.
Yeah.
Where one thing causes a chain reaction to the next, causes a chain reaction to the next molecule, so on and so forth. So yeah, it enhances.
Fernando's asking about using a CO2
the absorbing
reactor
media.
with yeah. So yeah, that's going to strip out the CO2, so that's going to purify the air. So yeah.
Absolutely. We utilize that in conjunction with drawing the fresh air in. We have that. We have activated carbon pellets also in line to take out all the friggin' odorous and malodorous smells, because odors also get dissolved into water. So that's one of the reasons why we utilize activated carbon to suck out, the smells out of the air before we actually pump it back in.
Now, have you ever tried using those CO2 absorbing the pellet that media? I suppose it works amazingly well, but it doesn't last very long.
Well, we utilize both litholime and soda lime. There's the two utilized for anesthesiologists. When you go in for operation, and a lot of the times they last for once again, if you're drawing in fresh air from outside, CO2 concentration is low. If you're drawing it from inside the house, that's already high in CO2. Yeah, of course it's going to get spent a lot faster.
Yep.
Does that make sense?
Yeah, no, for sure.
Yeah. So that's one of the reasons why people are saying, well, I'm utilizing a CO2 scrubber and it's not lasting long. Well, that tells you exactly the richness of your air and carbon dioxide richness in your house. Where the friggin' media turns pink almost immediately.
Yeah, it's burned up pretty quick. Yeah, it's can be pricey, so I've never actually used it. But one local guy I know that's trying on his tank, he says it's like a massive jump in pH, like right away. Like he was amazed how much of a difference it made on his tank from sucking all that CO2 and scrubbing it before it goes into the system.
Absolutely.
Isn't it essentially like a pelletized kalkwasser in a sense, like this little lime?
Well, we also utilize kalkwasser to actually strip out the CO2 as well.
Yeah. I thought about actually I thought about putting it in a reactor and letting the air suck through it to see if that'd make a difference, just for fun.
Like a water pipe.
Yeah.
Basically like a water pipe. And you'll notice that there's going to be calcification on the bottom of that reactor though. And it happens very, very fast.
Oh, really?
You'll see a lot of precipitate coming out if you already have a saturated CO2 level in your home.
Yeah.
And you'll notice that it precipitates out very, very fast in kalkwasser. Even in clear portions of it, as it's bubbling through, you'll notice precipitate coming out, which is also another good way to actually strip out the CO2 in your air.
Well, that's
do you know like why old school roofers didn't suffer so much of the problems that the new reefers do?
Because their houses weren't sealed like in bubble wrap?
No, it's because of how you want your system to run. Like I know you want your system to run silent. In the old days, we used to have crashing water
like a
that degassed the CO2.
Waterfalls in your tank, and you barely even know my tank's on.
Yeah, exactly, and that's so it's like then you've caused that problem because you're not degassing the CO2 through water crashing. So that's why in a system like that, then you need to countermeasure. So you think, I've got no crashing water, so I'm going to have higher CO2 levels, so I need to countermeasure that.
Yeah, so even that tiny airline outside made a huge difference. That and running the micro bubbles at night as well. Between the two of them, it's been a decent boost in my pH. Which makes me think now I should probably time to recalibrate the probe to make sure it's not lying to me. It's been 4 or 5 months. It's all false hope. But yeah, no, it definitely did
When
make a big
everything looks
difference.
good, check.
No, exactly.
Oh yeah, I mean, we get a very, very small swing in that, and in that turn, raising the oxygen levels, you're increasing your biological activity. Your biological filtration is boosted as well.
Mhm.
And going back to the whole, filtration topic, you have
Yeah, so I mean, the more oxygen in your tank, the more everything is going to thrive. So you're essentially feeding it to an extent. It's having all that extra oxygen molecules in there. All right. See you later, Ash. Orpus 350. Yep, no, 350 is a pretty good place to be. That's kind of, mine's not too far off. Mine's usually been
Yeah,
the
that's a good
300 to
level.
350 range. 296 right now. I have, I think I have it set to about 350 to turn off my ozone if it creeps up there. So I try to keep it around that level. So anyone that does use ozone as well, it's one of those things you want to, all is well in moderation and too much is trouble. So I run mine
correct.
very low and just for a couple hours a night. And it does a great job of, keeping that water crystal clear.
You're surprised how little you needed
Oh
when
yeah.
you put it when
No,
you tweaked it.
I think I'm just blindly guessing because there's no actual numbers on there, just on the percentage of the dial. So it's
Yeah,
probably around the 20 milligrams ish, and I probably run it for, I believe it's set at somewhere between 3 or 4 hours a night.
yeah. It's not a lot, right?
No, you don't need a lot.
But it makes a huge difference, though.
Yeah, you
Exactly.
don't need a lot. Just
Yeah.
like the microbubbling too.
Hmm.
You
Mm,
don't need vast amounts of air. You just need
Hmm.
a little bit.
Yep.
A little bit of freaking fresh air should not cause your temperature in your freaking water to plummet. Especially in the wintertime.
Hmm.
Even if you're bringing in fresh air to your skimmer, you're not noticing a huge difference in temperature, are you?
Hmm. No, I don't think so. I mean, the heater would balance it out, but yeah, it should be pretty minimal.
That's why,
Exactly.
like the
So
older methods of filtration we had, like shower filters and trickle towers and things like that. That's why we were aerating and also degassing.
Hmm.
exactly like
That's
the bio
with the
balls.
older methods of filtration we used.
Yep, the bio balls were a good one.
Hmm.
For actually breaking up the friggin' water stream and actually degassing a lot of the stuff, due to agitation and turbulent flow around it.
Hmm.
And believe it or not, that used to be a methodology of actually skimming out the water too,
Yeah,
utilizing, trickling it over, tennis balls and stuff like that, and also what is that called? The bio balls, right?
fireballs.
Right, Nick?
Yeah,
Yeah.
fireballs,
And then you
K1
get a foam
media.
head at the bottom. You get a foam head at the bottom of the friggin' of the sump. And then we were actually just taking cups and buckets of friggin' foam out and friggin' flushing that away. That was how we were actually exporting it instead of utilizing a protein skimmer.
Hmm.
Once again, going back to the Model T days of
Model
reefing,
T.
Got to crank your engine
the
and get
Model
her going.
exactly, and that was when we had the big gulp. So we were utilizing the big gulp cups to actually remove the foam, foam in the foam head off the surface of the water, after the bio balls.
Hmm.
It was a great way to aerate, and it was a great way to protein skim as well.
Yeah, I
I mean,
guess,
you
eh?
still see it. Yeah, you still see it in koi ponds,
Hmm.
the trickle ball
Commercial
filters.
systems.
Yep,
Yeah.
commercial systems where you have that foam head at the bottom, but then it goes to a freaking conveyor belt to actually freaking remove the foam coming out of the bottom side of it. But yeah, I mean, there was a lot of different ways to actually protein skim without protein, utilizing the modern protein skimmer.
Hmm. Well, yeah, no, exactly. I mean, micro scrubbing to an extent is, almost acting like a mini protein skimmer in your tank. So,
Oh,
Yes,
absolutely.
by flotation.
hmm.
Yeah, and that's one of the reasons why we also call it flotation clarification.
Hmm.
The micro bubbling actually floats out a lot of the particulates and clarifies the water.
Yeah. So,
It's very, very efficient for the amount of energy that you're actually utilizing.
yeah, between the protein skimmer, the microbubbling, my super trickle of carbon, and the ozone, it's like literally like crystal clear.
Hmm.
Someone's asking, do microbubbles affect clams?
No, it doesn't.
Yeah.
I've posted up a number of videos where it shows clams at low tide, and they're all exposed to air.
Mm-hmm.
Mm.
You know what I'm saying? It's like, you know, people are so scared to expose even coral to air. But I mean, we see pictures of low tide and corals are poking out and they're still alive.
Mm-hmm.
You know what I'm saying?
No,
And so yeah.
mm-hmm.
So go
Especially in
ahead.
like a lot of those low tide areas, like you see it where like the tide goes out and there's tons of corals exposed to air, and they're exposed to air for a few hours, and they're fine, healthy growing, and they adapt to it.
Hmm. Absolutely. So if you're having problems with bubbles in your clam is probably on its way out anyways.
Mm-hmm.
That's the only time that it actually retains bubbles and it can't eject it is when it's actually pretty sick. You
Yeah.
know, and I mean, same with fish.
Mm-hmm.
You know, a lot of people go, oh yeah, well the micro bubbles are going to get into the gills and they're going to lodge there. I've never seen a healthy fish have bubbles lodged in its gills.
Mm-hmm.
It,
I mean, if
it's
it
covered
moves,
in
the bubble's gonna float away.
exactly.
Just think of how.
So I guess I was a question about today. After dosing Nopox, I get a lot of cyanobacteria in my sump. It's in the back. Nitrate went down pretty good. What should I do? So you're seeing cyanobacteria after using Nopox? I haven't used Nopox personally yet.
Well, once again, it's kind of like vodka dosing and carbon
Mm-hmm.
dosing. If you're not aerating and you're not getting enough oxygen in, remember
That's
cyanobacteria is photosynthetic. It loves CO2.
mm-hmm.
That means that you're not degassing your CO2 well enough.
Okay. There you
And
go,
that's one
Frank.
of the reasons why, Frank, that you would want to increase your oxygenation and your aeration of your system. And once again, flow doesn't create oxygen bubbles.
Mm-hmm. Yeah.
The active pumping in of actual air is what actually increases your oxygen levels, and there you'll start seeing the cyanobacteria disappear as your oxygen levels increase.
Okay. So there you go,
It's kind
Frank.
of like
Drive up more CO2 and get more oxygen in the tank. So the other question is with sponges, because sponges aren't supposed to be exposed to air. And I think the question is more around, is there any issues using nano or micro scrubbing bubbles with sponges in the tank?
that is funny. You have to control the size of the bubbles if you're having a tank with sponges.
Mm-hmm.
You just have to
Yeah,
be very,
don't be
careful.
making your tank into a jacuzzi. You're
No.
talking nano size. A nano
Yeah.
bubble is like the width of your human hair. You're talking
Mm-hmm.
very, very tiny bubbles.
If you like a sewing needle, those little pinheads, like they're literally little specks. I see some people do it, and they have giant, like huge bubbles in their tank. You want them as fine as possible, like tiny, like we're talking nano bubbles, not
Where
this.
they almost look white.
Yeah.
They look like little white specks where you can't actually see the bubble.
Mm-hmm.
Mm-hmm.
Like I could have it on with my tank on, and I don't even really notice they're on unless you're like looking right at the output of the overflow. You can see these little white specks coming out. But yeah, super duper tiny bubbles for sure.
See, O's saying that he can't keep his pH up without bringing in outside air with his skimmer.
Mm-hmm.
See,
Correct.
somebody like O would probably benefit from getting, like we were saying, like an oxygen cylinder and just leaching oxygen in line.
But I was looking online
that
too,
would probably
those
help a lot.
oxygen concentrators. They're not cheap. They're like $400 online, but I was just curious to see. Be an interesting experiment if someone wants to splurge.
Yeah. Well, I
Just
mean,
keep
think
telling
about it this
Seymour
way
it'd be a
too.
good idea, and he'll
Right?
try.
Exactly.
We're spending $400. Yeah, we're spending $400 on the freaking skimmer itself, if
Yeah.
not more.
Yeah, that's
So,
relatively, I guess, not bad.
we're spending thousands of dollars on lights.
Mm-hmm.
We're spending thousands of dollars on coral and fish. And then when it comes down to aerating their system, they try to take the shortcut and say, well, I don't need that.
Mm-hmm.
You know what I'm saying? Go,
Yeah.
But
my
it's
aeration
weird
is
though,
good.
because
I have
if you
good turbulence.
but if the thing is though, Chris, it's weird because even like the fish, if you look at it, they have gills. Why? They have gills to utilize oxygen from the water.
Mm-hmm.
So
If
it
there's
makes
oxygen in the water.
yeah. So if you increase the oxygen saturation, how can that not benefit?
Mm-hmm.
Even your corals, everything. You've got to have oxygen in the water. That's what they're evolved to utilize.
Mm-hmm. No, very cool.
And I mean, we don't have enough water volume to actually create a a huge tidal wave that crashes on the beach. So we have to emulate that. The crashing of the water on the beach. The degassing right there. I mean, it's very loud. Don't get me wrong. So the next best thing, get a freaking air pump. You know what I'm saying? Get an air pump and utilize your skimmer.
Yep.
Both in tandem. It's not just one or the other. If you have a skimmer is good. As a backup to the Miracle Mud Refugium. We're not saying not to utilize a skimmer. Some people have successfully. But
Actually,
they also aerate.
here's an interesting question for you about using an air pump and a skimmer. Have you ever tried forcing air into your skimmer's intake?
Oh, absolutely.
Like, I don't know if the skimmer would have more suction or the air pump would have more push, but
you can get like if you take your inlet tube for your air inlet tube and you blow into it, you can over, and all you'll get is big bubbles, because what happens is the pinwheel won't break the bubbles up as quicker than you're blowing in. So that's where you got to be careful with forced air.
I was actually going to try that. I modified, like, what was it? Anyway, one of those little quiet pumps. I took it apart and I glued in like 1/4-inch push fittings, and I was going to try and use it in line with my thing and push air into my skimmer. However, the pump that I was using was just too loud, so I didn't actually use it just because the noise would have annoyed me, because it's much quieter once I modified it. But yeah, I did modify an air pump so I could use 1/4-inch push connectors on it.
Here's one for you then, Dev. Do you think that if you took your skimmer offline, do you think that you wouldn't get crystal clear water?
Oh, I probably still would. But I bet you I'd have a big drop in pH though. We're not sucking in that.
But you can bubble.
Air. I could. Yeah, I mean, I could hook up the bubbler to suck air from outside and do that instead of the skimmer.
Yeah. See, what we've done is we've also put the wooden air stone either outside, just right outside the intake of the the water intake of the freaking skimmer, and that way it doesn't have to break up the bubbles, with the pinwheel at all, and you get the really,
it's
really,
just
really
sucking in the tiny bubbles.
Yep.
Okay. And then there's other people that have actually drilled into their actual skimmer itself and dropped in a freaking air stone in there and put a barb fitting, one of those extended barb fittings, a connector type.
Into the body of the skimmer.
So they run the air stone with the pinwheel.
Inside of the skimmer.
Exactly.
Yeah,
I guess
why not?
The original skimmers were air stone driven anyway.
Yeah, they were countercurrent, yeah.
Well, I guess
still more efficient.
You would get the you probably get a little better performance out of your skimmer. You would get the pH boost from sucking it in. You would just lose little bits of micro bubbles in your tank to kind of lift stuff out.
Yep.
Running it that way.
Exactly. I just said, well, I mean,
Cruz, I was just saying
yeah, go ahead.
I just saying to Dev, like, because this is the other interesting thing for me is like nowadays everyone sees the skimmer as an essential piece of kit to reefing, right? It's like you can't have a sump without a skimmer. And I was just saying to Dev, like, what would be his concern if he took the skimmer offline? Does he believe that he wouldn't get crystal clear water, or that he would get accumulates of particles, or that his system would suddenly be really dirty? Because all of those, you can counteract all of those measures. With taking the skimmer offline, you can use bubbling, you can use bacteria dosing, you can do other things to negate the use of a skimmer. And that's why I said before, like, try not to use your equipment as a crutch, as see it for what it is and what it does. And it's a tool in the toolbox, but don't believe that you have to have a skimmer on your system. If you understand the reefing mythology, then you don't need to have a skimmer. Yeah, it does extract, it does do this, it does do that, but there's other ways of managing that aside from having a skimmer.
Yeah, and that's where the whole refugium versus skimmer came out. But once again, we've seen that a blend of utilizing the freaking skimmer with the refugium is also beneficial. You can actually if you're running your skimmer 24/7, believe it or not, over time, mechanically on this earth anyways, things break down.
Mm-hmm.
If you're actually extending, and reducing your skimmer time on, imagine how much longer your actual, skimmer will last, and the
Mhm.
pump will last. So if
Well,
you're running it only 6 hours a day,
That could be
you're
more
also still
efficient for your system than running it all the time,
correct,
and more
because not all the
beneficial
time.
because your system is having a break from being stripped.
and I used to do that. I mean, you're kind of making me question if I should do it again now. But yeah, I used to only run it, say, 12 on, 12 off.
Yeah, but by see, the problem is sometimes with the modern reefers is that they think that if they switch the skimmer off, all that brown, stinky gunk in the skimmer cup isn't going to be taken out. And why would you want that nasty brown smelly stuff in the tank? Well, what they don't realize is that quite a lot of that is good stuff.
Yep.
Yep. And
So
a lot of it's phytoplankton too.
Mm-hmm.
yeah, and food for your coral, and food for the copepods. And
Well, I know some
the
guys will
algae
take
and
a
everything.
squirt out of their skimmer and spray it back at the corals to kind of feed them as well. So
my skimmer's been off for a week now.
Mhm.
My system looks fantastic. Crystal clear water, clean sand, no particles.
I might try running at halftime and see if I notice any difference.
Yeah, because
But that's the thing. That's the thing,
out of
Dev. It's like sometimes overcoming the fear, of it must always be on. You do this, you must do that. You might find that taking it off, the refugium does better for having a break from being everything skimmed out.
Well,
I mean, when you have your skimmer off, what I would suggest is turn on your microbubbling.
Mhm.
Yeah, aerate. Yeah, aerate.
Yeah,
Sure.
because I
still
kind
need
of think
to
I'm going to see a pH drop if I turn it off because it's not going to be sucking in that outside air.
Yeah, but that's what I'm saying. When you turn it off, the
Well, if I turn it off, then I'd need to run a second airline outside or somehow tee it off so that they can both suck from the same line. Yeah.
Yeah, but that's why I was saying when you turn it off,
Mhm.
the uses it was giving you, then you negate those another way.
Yep.
So I'm not saying, just turn the skimmer off and that's it. Turn the skimmer off, but replace the aeration job it was doing with bubbling.
No,
Do
very
you see
true.
what I mean?
See, if I was to turn it off, I would only run it at nighttime because that's when the pH is low. And the skimmer, I feel, will pull a lot more air into the tank than my little microbubbling would. So, I mean, reverse light cycle would be the best way to do it.
It's worth trying because I think you'll probably see benefits from it in terms of your refugium growth, just general, your corals having more stuff in the water to take up.
Yep.
And then you might realize, actually, I was hindering the system by skimming too much.
Well, I mean, you pull out good and bad, right? So it's just pulling out.
Yeah, I mean,
skimmer doesn't discriminate. Whatever attaches that bubble's going in the cup.
Yeah, the thing is, it is still part of your filtration method, though. So one of the things to watch is things like your feeding regime. If you're feeding a lot, so you're relying on the skimmer to pull that out so that your feeding doesn't become detrimental, then it might mean that you feed a little less because you haven't got the skimmer to pull out the excess of the food as well.
Now, originally, I ran my skimmer part-time just because it was noisy and I didn't want to hear it. So I ran it when I wasn't around. But now, on the flip side, I also skim very, very dry, right? So it's not pulling out a ton of stuff. It's only pulling out, the thicker, nasty bit. So I feel like that has less impact on the tank too when you have a very dry skim versus a very wet skim.
Yeah, I mean, a really good way, and not many people actually do this or can do it, but one way to look at that is take some skimmate, fresh skimmate, and look at it under a microscope.
I shall do that later.
You'll probably be surprised at what you see.
I got a microscope. Like a little digital one. Not super fancy, but it'll do the job. Yep.
Honestly, take a slide and see what you see. And I guarantee there'll be a lot of life in there that you don't realize that you're skimming out.
Huh. I'm going to try it. This will be good. Thanks for the inspiration. On this note, guys, I think I do got to wrap her up pretty quick since it's been almost 2 hours and
no problem.
Got to get some stuff done. It's been a great talk tonight. Thank you.
Problem.
Thanks for joining, Nick, and Cruz, who's no longer here, but thanks for popping on. hopefully you guys in the chat learned lots of stuff tonight. It's been a very interesting talk all over the place on saltwater filtration, from very old school methods to a bunch of the new stuff. So if you guys enjoyed it, as always, hit that like button. And if you're new, make sure you're subscribed and hit that bell. All right, guys, have an awesome evening, and thanks for hanging out.